Good morning and thank you for joining us for the British Amateur Television Club CAT23 Convention Part 2 online. I'm David G0MJW and together with my wife Tammy M0TC, who's on sound and vision mixing just over here, we're very pleased to help the club produce CAT23 today, which is being broadcast live on both the BATC streamer and the BATC YouTube channel. The BATC chairman is Martin G4FKK. And as well as over 40 years in professional broadcasting, mostly with the BBC, he has been active in amateur television since the 1970s and currently uses a port stand transceiver with an extra Arduino and touchscreen system to control switching, sequencing and other housekeeping functions. So now over to Martin, who will formally open CAT23 and give you an update on the British Amateur Television Club. Martin.
Thank you, David. Nice to see you again this year, doing all the production for us, and morning to Tammy. And good morning to everyone who's watching. Thank you very much for joining us on the BATC CAT23 Part 2. I'm going to keep it brief, you'll be glad to hear, but just to say that the club's had another very busy year, as well as the in-person CAT23 at the Midlands Air Museum earlier this year. We've been supporting various rallies and events, including the RSGB convention last week, which went well. And coming up, don't forget, we'll be at the Day for the Radio Amateur in Zwolle in the Netherlands. That's on the 28th of October. So if anyone happens to be in Holland or you live there, then you'll be able to see the BATC stand there. And don't forget, of course, our weekly net on Thursday nights at 8 o'clock British summertime at the moment. On QO100. And just a quick tip, the times on the schedule you'll see in between speakers are in British summertime, so hopefully that won't confuse people. Membership at the club remains strong. It's about the same level as last year. CQTV has been packed with some very interesting articles. We're always looking for articles for CQTV, so if you feel the writer in you, please make use of that talent and send it to us. And talking of the membership, I'd very much like to welcome Tony G3UIS to the committee. He very kindly volunteered after my desperate plea in CQTV a few months ago, and he's about to take on the membership secretary role when Rob G8NXG steps down, which is I think it's this month actually. So I'd like also to thank Rob for all the many years he's put in looking after the membership secretary details. That's much appreciated. Talking of volunteers, we're always on the lookout for willing people to help out at events and rallies and the aforementioned stands at the various things we attend. And if you're keen to take on a more active role in the club, then please let one of the committee know, and we'll definitely find something useful for you to do. And I think you'll find my email address has just popped up, so feel free to email me anytime. With regard to today's event, you can send questions while you're watching the speakers speak. If a question occurs to you, put it on the chat on the BATC streamer, and David will moderate the questions and make sure that the speaker gets to hear what you've been saying. And there'll be a few minutes for Q&A after each speaker, so that should be good. I've noticed the events also currently on QO100 being shown by Mike, who's in a QSO with someone else. So thanks for that, Mike. That's looking good. So I'd particularly like to thank David and Tammy, who are doing the production and streaming facilities today. Without them, this wouldn't happen quite as slickly as it seems to every year. So I'm going to hand it back to David to introduce our first speaker, Tim, and have a great CAT23 Part 2. Back to you, David.
Thank you, Martin. Now I'm pleased to introduce our first presenter, Tim MW0RUD. He's first licensed in 2015, and Tim is a professional software engineer by trade, and so inevitably ends up writing radio-related software such as the firmware for the BATC Ryde ATV receiver, which is going to update us all on today, as well as share some of the future plans. And I'm pleased to tell you that, just like Martin said, you can ask questions or make comments at any time using either BATC messaging or YouTube chat during Tim's talk, and I'll read as many of them as I can to him after the presentation. Please include your first name and your call sign if you have one in every message. So now over to Tim. Welcome to CAT23, Tim.
Thank you, David. Yes, so I'm going to talk about the Ryde. Inevitably, I end up, as David said, I end up writing the software. Also, I inevitably end up doing more writing of the software than I do of using it. I do a lot of the satellite operating, receiving with it. But yes, I will quick introduction to what we're going to talk about. So I'm going to do a quick introduction to what the Ryde is for anyone who's new. And then I'm going to talk about some things since I gave a talk 2 years ago, new things that have been introduced since then. And then what the kind of things that are coming up down the line. There's always new features to add. And then going to give a bit more further explanation on some of the features in the config file, because that seems to be something that people always need a little assistance with. So, what is the Ryde? It's designed to be a set-top box, but it will do the narrowband modes that we use as amateur radio, that more efficient into the bandwidth, that are technically outside of the spec, so off-the-shelf receivers won't do it. It also has a wider tuning range. It uses all the features of the mini tuner. It also has quick access to things that are more difficult with a traditional set-top box, such as the frequency and bandwidth. Normally they're buried away in a menu or even completely inaccessible, and you have to scan for channels. So at the moment, you can access them from the menus very quickly, and all of these other things when we get to make our own software. The changes that we'd make compared to a normal receiver. It's built with a Raspberry Pi and a BATC tuner, as you can see in the picture. Yes, it's designed to be very easy to use. You don't need a computer. Certainly once it's set up. You can use it entirely without a computer. You can buy a SD card from the BATC shop and put it into a Raspberry Pi, plug it into a mini tuner, and there are some defaults. For setting up your own infrared remotes, you probably will need a little bit of assistance from a computer, but that is only for the setup. Once you've got that configured, you then won't need a computer. So finding someone to help you with that is, if you're struggling, is not an ongoing task. It's used for a lot of repeater inputs, because again, it's just HDMI output or a composite output. So it can go straight into any repeater, and as I said, it works on all these the narrower bandwidth, so it's been quite popular. Lots of people also have them for shack displays and satellite receivers, for things like QO100. Yeah, so that's the basics of what it is. So since 2 years ago, we added some new features. Some of these were coming down the line. Some of these are completely new for a while. The RTMP stream, so BATC streamer receiver, again useful for repeater inputs. People who have receivers, people who have stream receivers. It reasonably reliably receives it and outputs the same things like a lock signal, which is useful for repeaters. I think some people do watch nets and things on them as well. To combat some issues we've had with things crashing or hardware problems, I've created a pair of watchdogs. So there's an internal watchdog that if there's things like hardware failure, your mini tuner gets disconnected or loses power or something, it's now capable of watching for that, and it will recover automatically. what if you reconnect it or fix the problem, or occasionally we get strange RF events that will cause some of the internals to crash, or Longmind, for example, can crash under certain strange events, and Ryde now keeps an eye on this and will restart these things if they fail. There's also an external watchdog that it will service. So periodically the Ryde software leaves a note to say, hey, I'm still here, I'm still working. And then there's an external piece of software that Dave has made that just watches for these little updates. And if it hasn't heard one for a while, it means that the Ryde has crashed or it's locked up. And then the external software can restart it. Occasionally we find odd bugs or strange environments that have caused crashes, and we've added these features to make it a bit more resilient for unattended viewing again. Things like repeater receivers or demonstration stations. For example, there is now a demonstration station at the RSGB National Radio Centre at Bletchley, and they've had some issues, some of which to do with the interactivity they're adding. A much requested feature that I've had since it first came out has been longer menus. We've had problems with there being more people wanting more presets than will fit on the screen. So I had some design issues and some slight technical flow issues to solve to get this working, but now I can say that you can have as many presets as you like. Obviously, if you have a lot, you're going to be forever scrolling through the menu, but now it will expand the menu up to fill the screen, and then if you add even more, it will scroll, so you can have a lot of presets, which now makes it much easier to navigate, as before they would go off the bottom of the screen and you were trying to navigate the presets blind by counting how many button pushes you had to do. Again, yeah, that's very popular, requested. Another feature we've had, the way that features get prioritized, it's to do with kind of use cases. So lots of people ask for scrollable menus, but people like repeaters, keepers, and engineers asked for some ability to display things on the screen. Some custom text for things like call signs or repeater receiver identification. So there's this player ID. It will automatically generate a player ID if you don't specify it in the config file. I'll give a bit demo of that later. The player ID will display on screen, so you can add some custom text to the screen, particularly useful for repeater receivers, or if you have multiple receivers, so it's a bit easy to keep track of which receiver is what. So if you have a stream receiver and a satellite receiver showing you the same thing, it's a bit harder to get lost if it tells you on the screen what you're looking at. And inevitably, the other thing that's always been going on is there's always small fixes, people finding bugs, little tweaks to things. There's always a fair amount of new things coming down, or like hardware changes. Okay, so that's where we've been, and this is where we're going. Now, I've included Raspberry Pi support as a upcoming feature. My Raspberry Pi 5 has not arrived yet. Hopefully it'll come in the next week. I'm not promising anything on timing because there's a lot of unknowns. I've got my fingers crossed that it'll just work, but I've got some concerns that I might need to do some not insignificant development. It depends how much things they've changed, but we'll find that out when it arrives. There is no need to worry about getting a Raspberry Pi 5 at the moment. They're quite hard to, they're all back-ordered till next year at the moment. But a Raspberry Pi 4 does just fine. You don't need to worry about it. It's just that for some potential future software upgrades, we may benefit from some of the improved speed of it. You might get a slight power saving if you use it, because they say that it will use less power for the same workload. Obviously, our standard workloads aren't changing. There's various things to do with the transport stream encoding that need to be upgraded. We have to handle, at the moment there's some problems with things like multiple streams, so with transport streams with multiple programs in it, but also the way that the data flows through the software currently causes some issues to do with adding future features. So I need to add do some behind the scenes work on some transport stream handling capabilities, which will then make it easier to do other things with the data input. For example, the recording and streaming. So this is input recording and streaming. This is not, there's no re-encoding. So this is designed for recording the input TS, and it will separate these things out, separate them out by signal. So if the signal goes away and then comes back, it ends up in a different file. But this is raw, so this is design, and it splits the files out so that if there's codec changes, if you're recording a net or something, it will split them out so for easier re-encoding. But this is the raw stream. This isn't for streaming out. Again, with streaming, it's not for streaming to the BATC streamer or anywhere. It is for streaming out to an application designed to receive it. It is the raw input. So things like the transport stream merge for the International Space Station, that requires a raw stream for the transport stream to go out. And that, so we'll want to add the ability to do that, ready for when that is back on orbit and receiving, so that people can view it on their ride and stream it out and record it at the same time. So other upcoming features. Now, I've been doing some initial research into SDR support. This probably is going to require the Raspberry Pi 5, and it's probably going to come in several stages. Probably there's going to be an initial SDR support, so you can use probably two SDRs, because they're the ones I have, and it's probably not as it won't be as sensitive as a mini tuner. So it's not a replacement for the mini tuner at the moment. It's more of a development platform for people, because there's some improvements that need to be done to the SDR software chains that are pre-existing. So they're going to need further work. So if I can provide a platform for that, it will make it easier for everyone else to make improvements. But yes, as I said, Raspberry Pi 5, because it is very computationally intensive, but we'll see how the Raspberry Pi 5 does when these things come. So yes, hopefully we can get a development platform that is worth it, and then people can make some improvements, because at the moment the sensitivity is not good. It's about 2 dBs difference between a mini tuner and an SDR, so definitely some software. I've said this before about upcoming things. The on-screen config, I think I've mentioned this several times in several talks, that is upcoming. There's a lots of things keep getting in front of it. Lots of changes, lots of whether it's work steals time from developing Ryde, or whether it's new Ryde features that need to be built ahead of it. Because the idea is that there's an on-screen config, and the on-screen config will will make the necessity at the moment of the console menu. It will reduce that necessity. But first, I have to have it so that any config file that you pass into it, it can pass out of it, and it be the same. And then I can start building user interface components to let you modify things, probably presets and patterns first. So we'll see how that goes. Again, it's reasonably low down the list in terms of upcoming features, but it is an important one. It really will reduce the necessity to have an external computer for the setup, and will reduce some of the limitations we currently have using the console menu to write the config file. There's potentially some small UI improvements. and other things coming down the line, and inevitably new and exciting features that I haven't thought of yet. There is always the potential for new features. A good way to get, if you've got a feature that's upcoming that you think is missing, as with all volunteer-driven software, the way to get it done is to get the person writing the software excited about it. That's how the priority works. If I'm excited about the use cases or the feature itself, or it sounds like an interesting technical challenge, do file an issue. So yes, there's always these. So there's always options to things, and things can skip the menu, skip the queue. So like Raspberry Pi support suddenly skipped up the menu. Raspberry Pi 5 support skipped up the list when it was announced, because I thought, oh, that sounds like an interesting thing I should probably check, and the hardware looked interesting. So now some quick thanks before we get on to talking about the some config file things. Obligatory thanks, particularly to Dave. He does all the build managing, and he manages the database of handsets. He does all the alpha testing, and is generally very useful for things. Heather, who wrote Longmind, and Phil, who's been doing a lot of the maintenance and little feature adds and adjustments. And Charles, who wrote the Knucker support. And of course, thanks to all the testers who point out things that are broken, or something's changed, or I've broken one thing while fixing another thing. There's always bugs, always a thing to chase, and if it's a feature that I don't personally use particularly often, then obviously the people who do use it will notice and let me know, and I can sort it out. So that's kind of an introduction to where we are and an update. So now I'm going to give some more information on the config files, as they are a continuous, periodically get people who are having trouble trying to make modifications, or people who say, oh, can it do this? And it's like, yes, but you have to edit the config file for it. Again, some of the on-screen configuration features later will hopefully make some of these more obvious, but for the moment you've got a config file to manage. It's mostly managed by the console menu at the moment, for setting your presets and your bands and various other settings. Updates, if you've made custom changes, occasionally we have to reset you to the default config when there's updates, because things have changed. Also, if you make manual changes, then the console menu will tend to override them. So the files itself, I'll show you an example in a couple of minutes. The files themselves are YAML files, which is a standard format. It's got this hierarchical indented file format. It's indented with 4 spaces, specifically 4 spaces. We've had various problems with which I suspect have stemmed from people using tabs or the wrong number of spaces. Every indentation level is 4 spaces. The easiest way to edit it and to maintain a valid file is to edit it on a computer and then check it with a validator. There are various validators on the internet. So what I recommend you do is you copy the file to your computer with any SFTP file transfer, particularly SFTP or SCP. There's a few different names for the things it supports. It doesn't support standard FTP, but yeah, you should be able to find an application, find a recommendation for a way to get that file onto your computer. I would then recommend you make a copy of it, so that if there's something goes wrong with your editing, you can then obviously put back the previous version. Always do your backups. And then you can then open it up. If you open it up in any text editor, if you open it up in a slightly smarter editor, things like Notepad++, something that will assist you with the indenting, it will be a bit more likely to get the indenting right. And you make your changes. I'll go through a list of various things you can change in a minute. And then You can run it through an online validator. YAMLlint.com is an example. There's lots of other examples of validators. There's lots out there. They do different levels of validation or cleaning and tidying for you. That will then would check the file for YAML valid, which means that the Ryde will then accept the file and attempt to interpret it. If you've made certain kinds of mistakes, from then on, generally it will import everything that is valid. So if you've made a typo, it will import all the things that don't have a typo in them. So if you've renamed one of the sections by mistake, for example, then it will potentially not load that section, but it will load all the other sections. So if you're editing the on-screen display, and you make a mistake and that section is invalid, it will hopefully still load all the bands and the presets. There was a complete list. It's now getting quite a long list of what is in the config file and a full description of all the settings on the GitHub at the link that's on the screen. We also have, I'm going to go through them in a minute, go through some of the sections and give some examples. So generally the file contains these are the primary sections. The default file has 234 lines, I think, and the sample file that I provide, which is different, is 266 lines. The default file is a good example of all the settings, as well as being a good place to start. And we provide it by default. It's got a lot of good presets, sensible presets in there. The sample file that is provided with Ryde software specifically is designed to be a sample of demonstrating things you can do. It is not designed to actually be used. It's more like, I'm not sure how to do this slightly unusual feature or this setting, and the sample file there, we've generally got examples. So it does some very odd things, and it's not generally the file you want to be running. Okay, so these are the broad sections. So config revision is mostly an internal setting. It's there for me detecting when I've had to make structural changes to the file. Generally, you should leave it alone. I think the current value is 3. Player ID, I'll go into more detail in a minute, but that's the player ID idea I mentioned for drawing some on-screen stuff. Sources are things like Longmin and Combi Tuner. It is the global settings for like the mini tuners, global settings that apply to all bands and all presets. Bands, they're designed to be signal flows. So anything that's got the same IF and comes in through the same route into the Ryde will be all in the same band. So that if you're tuning your LNB offset, for example, then you only have to tune it in one place and it will apply to all presets that use that band. Presets are what they sound like. It is a set of symbol rates and frequencies, for example, or various other things that are a specific channel for receiving specific data. The default is usually a reference to one of the presets of where you want what channel you want to come on when Ryde starts. There's an infrared section that is all about setting up your infrared remotes. Some of these, I'll go into some of these more technical settings for that in a minute. GPIO is the same. It's for the button board, for any buttons you've got, or other GPIO settings like the band output settings and the lock light. OSD is for all the on-screen display settings. I'll give a few examples of that in a minute. Network, you generally want to leave alone. In there, it's to do with like the bind port for the network API, but it's settings that you might have to change if you're doing particularly technical things or you have conflicts. But generally, you need to leave those alone. The watchdog and the watchdog service. So the watchdog is the internal watchdog to do with monitoring things like Longmin, and watchdog service section is to do with the external watchdog about where it writes its tracking file. Shutdown behavior is all to do with what happens when you push a power button. To do with, do you shut down the Ryde, do you just close the software, do you reboot, what the defaults are. Audio is mostly things like volume control, default volumes, mute, not mute, as well as whether you want to enable the volume menu. The volume menu is only really useful at the moment if you don't have direct volume control buttons on your remote control. Then you can use the volume menu to adjust the volume on the fly, rather than having to edit the config file and then restart it, or have multiple rows or something complicated. And then there's a debug menu. Generally, you want to keep out of the turn the debug menu, leave the debug menu off, and there's a few settings in there. Generally, we leave them at the defaults. It's things like, therefore, debugging. We might ask, if you're helping us solve a problem, we might ask you to change some of the settings in there to try some different options. There's things like a different text rendering that supports emojis, but has other disadvantages, and it causes the Ryde to crash periodically. So you can turn that on and off, but we kind of introduce some of these prototype features in there. Okay, so this is what the default config looks like. It's very long. This is the sample config. Sorry. Yes, it's designed to show off what's possible. Yes, you can see there's a config revision 3. I know it's very small, but yes, it shows you quite how long it is, but does give a decent demonstration of what's in there. Just as an example. Okay, so now I'm going to go on to some examples of specific changes you could make depending on your specific use cases. So, for example, this is quite an old screenshot now. I think I've shown this example before. So the on-screen display has 3 sections. You've got one to do with timers, and then an active and an inactive. So when you push select or the on-screen display on a dedicated on-screen display button, it brings the on-screen display becomes active and then will deactivate according to the timers. Also, the program stream, like the transport stream, if the new signal comes up, it will automatically activate it, and the timers at the top are to do with the triggers for that. I think I'll go into a bit more detail on the next slide. But if you just want the signal level to be there all the time, you just need to add it to the inactive section. So you see here, I've taken the signal level, and it's both in active and inactive. If you moved it instead of copying it, it would then disappear when you activated it. The null, I'll talk about in a second. Essentially, it means leave it in the default location. So yes, this brings us the MER up and leaves it up all the time. So some other kinds of changes you might want to make is, for example, this. I use this when I'm aligning my dish. So I go in and I adjust the user trigger, which is when you push select. If you set it to null, it will never time out. You can push back to get rid of it, but it won't time out on its own. If you set it to 0, it'll never come up. You probably only want that for the program trigger. So these are the timers in seconds on these lines. So the program trigger, if you set it to 0, when the signal changes, it won't pop the on-screen display up. So in this example, the rest of this example, I have deleted a lot of the other on-screen display sections, and I have moved and resized the signal level, which is what you want for aligning a dish. And I've just made it as big as possible. So the way that this works is you replace the null with a subsection that's got these 5 fields in it. So datum tells you what the reference is. So, for example, the center, CC is center. So it will align the center of the center of the screen and the center of the on-screen display module that you're talking about. and then any XY offset is relative to the centers of the two things. Excuse me. But the top left, you can do top left, top center, top right. A lot of the default, there's a lot of modules that are all related to the top right, and then some in the top left, and the bottom center is where like the program box displays that tells you like, the channel you're tuned to and the received information, whereas all the signals, a lot of the signals are connected to the top right. So yes, you can all four corners, all four edges, and the center of the screen. So, and it's all, and then your XY is if you want to move it. So if you're referring to a corner, you can then push it out from the corner a little bit, or push it down from the top. Using XY, these are all fractions of the screen. So 0 is the same place, 1 is a complete screen across. So that you'll find small numbers in the default configuration. Width and height are the same relative to the screen. So width says 100% width, width 1 says 100% width, height 1 says 100% height for the module's box. And then it will try and draw all the settings within that box. Draw the relevant module within the box that you define. So in this case, I've got a module in the middle with 100% width, 100% height. So I've got this big MER display in the middle of the screen. The other thing, this is one of the new ones, is the player ID. Player ID is auto-generated, but you can also specify it. For example, in this example, I've got dev player set, but you might have that this is a stream receiver input. So you specify that at the top of the config file, just below the config revision, and then you have to make sure you add the player ID module to your active or inactive or wherever you want to display it settings. It follows all the same alignment settings, and you just get a little bit of text. So as you can specify that text, yeah, you can make it say whatever you like, but you can also move it around and resize it as necessary. Using the settings I showed you on the previous slide. So if you want to make it bigger, if you want to make it more obvious, put it in the middle of the screen, I don't know. It's just a little bit of text you can add. By default, yes, there's an auto-generated setting based on the serial number of your Raspberry Pi. So if you have multiple Pis with the same config, they will have different player IDs. So that's most of the on-screen config setup. Now, one of the other things when I was talking to people last weekend, people were saying they had problems with debounce on their buttons and on their remote controls. So that's, you push the button and you get two pushes. Like if you're scrolling through a menu, it jumps 2 settings. Or if you're pushing the like an on-screen display button, it kind of pops up and goes away again because it thinks you pushed it twice. So there's some settings to do with debouncing. So I've drawn a little diagram. I don't know if you can read it. You can probably, if you have you might need to make the screen a bit bigger, watch the video back later. So there's 3 settings in here designed to reduce accidental repeated inputs. And I think the defaults are probably too short, and we can look at changing them. That work for both the infrared and the GPIO. So I've done this example. So the big thick black horizontal line is when you're pushing the button, and the little vertical arrows are when the events will go off. So, and then the little horizontal arrows are examples of the individual timers. So repeat first is the time between the first instance and event and when it starts to rapidly repeat. So when you push the button, it will wait this long, currently set at 200 milliseconds. By default, probably should increase this to reduce some of these issues. And then if you keep holding the button, it will then repeat at repeat delay. So every 100 milliseconds, so 10 times a second, it will push the button. So as you see, there's a big gap before the first one, and then it repeats. And then there's the reset delay, which is how long do you have to let go of the button before you then it will do the repeat first again. So the repeat first section, so any gap under 400 milliseconds in the default it will ignore. This is to do with the way some infrared remotes work. They don't tell you when you push the button and when you let go. They just keep sending the signal repeatedly. So we need ways to tell the difference between these things. So the first red section, when you're not pushing the button, it won't necessarily detect it. So if you let go and push it down again, that timer hasn't expired, and it will keep repeating at the high rate. Whereas after the second gap, the green gap, it will then wait that longer first repeat time before going into the rapid repeat. So yes, I think we need to do some tuning with this. These settings were back of the envelope, I was just playing around with them. Playing around with the settings kind of worked in my test setup, and we've not really revisited it, so potentially these should be extended, because 10 times a second repeat and only 200 milliseconds between the first and the repeats, definitely a bit short, particularly because of the way it works. If there's some lag in the software, it will then if there's lag in the software, it will, because it's to do with when it processes the event and not to do with necessarily when the event happened. If you have a lag, it will potentially be quite a long time, and you will get the multiples because it thinks you've pushed it several times. There's a few instances where I'm still looking at reducing some of the lag in the software, but things like when you change sources, so if you go from a stream receiver to something that's receiving on mini tuner or vice versa, there tends to be more time while it resets some of the internals, and it causes a little bit of lag, and you might have some problems navigating. But yes, if we increase these, feel free to go and increase these times. Be interested if anybody finds a good balance that's not too slow, but has a lot less bouncing issues. I think that's probably everything. So now I think we're gonna hand back to Dave to see if we've got any questions.
Thanks very much, Tim. It always amazes me how much work goes into something like this. I'm afraid I'm an old-fashioned chips and solder man, really, and so code had sort of kind of left me behind. But it's incredible the work that you put into to make this stuff, and how flexible, of course, that makes the design. So thank you for the presentation. Thanks for all your work, of course, on this as well. And this is a great time now for you at home, if you haven't already done so, to ask a question or make any comments for Tim, any questions on Ryde or any aspect of it. As you probably know, later on in the day, Dave is going to talk about the specific problems of the tuner, which we've got to replace. But other issues at all, the software, maybe a wish list. Tim, if you still have some, if you're still open for some ideas and things. So let's have a look. I don't think we've got much at the moment, but actually saying that, I've got John.au says, thank you, Tim, for the fantastic Ryde. Is there any possibility for the Ryde, in addition to RTMP stream receiver, to support SRT? We would love to use the Ryde and SRT in our repeater installations.
I'm not entirely sure what SRT is. We have I have looked at adding some more video stream codecs. For example, the RTP and RTSP settings, but they're quite involved. If there's a specific one that you're looking for, go and find the issue tracker and file an issue, and then I can have a look, and that's a good place to go and thing. It's on the GitHub. It should be linked. There should be links to it around. But yeah, go and find it if you've got specific hardware software requirements or something. Particularly, like, I'm keen for repeater inputs. I'm a bit more willing to put a bit of effort if it's going to assist multiple people. So yeah, please go and find the issue tracker on the GitHub and file an issue for that one, and I will have a look at the details about how complicated it is. Potentially, it might be quite easy, but some of them, like as I said, the RTSP I recently looked into, and it requires a reasonably extensive amount of work to get that working. So it's not particularly high on the list.
Okay, John, remember Tim's great tip earlier on. You've got to excite the programmer if you want him to do it. So hope that helps, John, anyway. So if you can add any more details on your question if you want now that I can read back to Tim, but best to put it on the GitHub as he suggested. Now from Mike G0MJW, he said, here's a general question. How about a Ryde running on an old PC? What are the challenges?
So the Ryde is very specifically designed for the Raspberry Pi hardware. Some of a lot of the video stuff uses the Ryde's, the Raspberry Pi's GPU to do the compositing. So at the moment, that is probably one of the primary things that would stop it running on anything other than a Raspberry Pi, because it needs these GPU functions. Again, potentially I could composite in software or in a more generic fashion for doing it, but yes, it's built out of layers. The Raspberry Pi's GPU currently does all the layer compositing, so drawing all the things over the video, for example, the video is on one GPU layer and the menu is on a different one and the on-screen display is on a third. So all of this compositing and this layering is done by the GPU, which helps with the performance of the Ryde. There's a few other things, like obviously you don't have GPIO on a computer. But yeah, potentially in the future I could make some of these modifications so it was less dependent on the Raspberry Pi hardware. But yeah, then it would run on any Linux computer probably.
Okay, thank you. Mike has just come back and actually said, thanks, Tim. This is less relevant now that Pi 4s are available again. Of course, there was a huge shortage, wasn't there? I think they're pretty freely available now, though I guess a lot of people might be putting that off for the Raspberry Pi 5. You talked about generally it's next year, is it? I did see the adverts come. I thought, well, I haven't done much with my Pi 4 yet. I better not order a Pi 5. But they're sort of, so we're into availability early next year for Pi 5s?
Yes, I think for new orders, I think it's going to be next year for the Pi 5 now. Possibly a little earlier, late December. But yeah, the pre-orders, I think the pre-order times are currently about there. I ordered mine on release day because I knew people would ask the questions, and for development. So I've ordered mine, so mine should be in the first batch. But yeah, I think we're into batch 3, which is early next year. Now, for most of them, there might be some slightly better availability on the 4GB version than the 8GB version. You might get them in the earlier batch, but yeah, generally places seem to have first batch is sold out, which is the one that's supposed to be next week. Second batch, I think, is late November, early December, and then the third batch is early next year.
Okay, thanks very much, Tim. Actually, related to the Raspberry Pi 5, Phil G8XTW says, with no audio out on the Pi 5, just embedded on HDMI, what are your thoughts on this?
So generally, I would recommend using HDMI displays anyway. But one of my test setups here is an HDMI to composite converter plugged into the HDMI on the Ryde that then will output the composite and the audio on the 3 plugs. So you can still do that with the HDMI. There was also the potential for you could plug in a USB sound card, and then people have done it before, the change you have to make if you've got HDMI output and analog audio, you've had to make some changes. You probably have to do something similar to get that working. But again, some of these things don't quite know what the best way to do it is, and we'll see when I get my hands on a Pi 5 and see how it reacts. There's a lot of kind of unknowns about exactly what changes they've made. But yes, apparently there is technically audio on the board somewhere. It's just not on pins you can get to. So we'll have to see if anyone finds that. There's potential also for audio out via the GPIO pins, but I think we're probably using the necessary pins for other things. But yeah.
Yeah, I doubt they changed the
questions for next week.
Yeah, absolutely. I doubt they changed the format of the IOs and things at this stage, because they want things to be backwards compatible as much as possible. But anyway, as you say, we won't put you under pressure. That we'll wait until you get yours, and then I'm sure you'll let the community know as soon as you can. John, by the way, John -AU, possibly from Australia, I guess, says SRT is another protocol, another library addition to FFmpeg. So that's what it is. But hopefully, John, you'll put this onto the GitHub as Tim suggested. Okay, we haven't got any other questions, I think, at the moment. We've got several people watching from all over the world. We've got Paul OE8 PCK watching from on holiday in Budapest. So I don't know what the weather's like where you are, Paul, but hopefully it's a little bit drier than it has been in the UK. I think most people have had some rain. Nothing else particular, I think, to mention at the moment. So I think that's probably it for now. Tim, thank you ever so much, as I said earlier, both for your presentation, but even more importantly, all the work that you put in, the dedication that you put in for this to support the community. I've got one question, if that's all right, just to finish on. And the Ryde itself, do you see that this is going to be a continually evolving project, or are there times when you sit back and think, you know, if I had my time again, you know, clean sheet type design? What do you think?
Yeah, I think we can keep going. It's all open source, so even if other people can assist, I will accept code changes. But yeah, I think as like Dave's got to talk later about the potential problems with the mini tuner and potential replacements and issues. So as we've seen with other things, as new hardware comes out, it's built in a way that's reasonably modular. It's designed to make adding new hardware support reasonably easy. So yeah, as new hardware comes out, I have to kind of keep up. But hopefully hopefully we can keep going. Like there's a long list of things. As people will tell you, software is a never-ending thing to chase. There's always new features to add. People come up with new features or new hardware, or things change, and you're always chasing it.
Great. But so you're still encouraging people to send in ideas as well.
Yes. Yes. Always look for ideas of new, interesting things to write, because I enjoy writing software. I enjoy the challenges that it comes with, and it's a good excuse, and it's better than writing kind of toys for myself that make something useful for other people. And for people like yourself, like you said, you're more kind of a solder and building the hardware person. So if I can write the software, you can then build the hardware, and you don't have to worry about it, and still get the project.
Absolutely. Well, thanks ever so much. Your enthusiasm is infectious, and we're really grateful to you, all the work that you've done. Thanks ever so much for joining us today, Tim.
Thank you, David.
Thank you. And as I mentioned, in fact, we've got Dave coming up with an update at midday on the mini tuner and the challenges to get a new piece of hardware for that. But that's coming up at midday. Coming up next, we've got a talk on KiCad PCB design software and ordering boards with Mike G0MJW. Just time to make a coffee. We'll see you at 11. Welcome back. Our next speaker is Mike G0MJW, who was first licensed in 1983, and he particularly enjoys microwaves, propagation, programming, making things, and of course, DATV. He also designed the club's popular POTY patch antenna project. Today, Mike is going to give us an overview of the KiCad PCB design tool and also tips for ordering printed circuit boards. As before, please feel free to ask questions or make comments on BATC messaging or YouTube chat at any time, and please include your first name and your call sign as well. Welcome to CAT23, Mike.
Okay, thank you. Sorry, I'm not seeing you, so I'm working blind here, but hopefully all is working well.
We can see you fine.
Yep, great, excellent. So could we start the slideshow, please? So, no, not the desktop, the slideshow.
There we are. Sorry about that.
We
just to explain to everybody at home, we're playing these out for technical reasons so we can get the maximum quality from your PCB design software.
Yeah, exactly. So I'm not doing this as a video stream. I'm doing this as a screen share. And of course, I can't put the image that I'm looking at on the screen share, or it wouldn't work. Anyway, could we go to the next slide, please? There we go. So what I'm trying to do is show you the basics of KiCad, and then you need to work from yourself. Basically playing with it is the way to learn how to use it, but it can be a bit daunting at first. So what we've got a very, very simple proposed sort of amplifier, which is a Galley 59 Plus. Now, I'm sure people have seen those before. They're simple game blocks, and this screen is really showing the parts from the data sheet and the design. I'm not going to go into RF design here. That's not the point of this talk. But the main things to note are that you have a chip, and it requires several components. It requires DC blocking capacitors. It requires bypass capacitors. It requires a bias resistor, and it requires an RF choke. So could we go on to the next slide, please? So the first thing you do whenever you want to build something is you look to find out what the components are and what the packages are, and ensure that you can actually get hold of them from one of the suppliers. Now, I've used Mouser here, plenty of other suppliers around. The advantages of Mouser and DigiKey websites is that they often have 3D designs or data sheets or footprints for the components. So could we go to the next slide? On the footprint side of things, the only issue you might have with using KiCad is when you've got a part that doesn't have a specific footprint. So this particular one, the Galley 59 Plus, is in the library, in the KiCad library. One of the reasons for selecting it, of course. Typically an SMA footprint is in there as well. So that's why I've selected SMAs and the Galley 59. The other point is this is all surface mount. No apologies for that. You can't really get these parts in through hole. So if you want to do something, you're going to have to do it in surface mount. But actually, they're pretty big and not too hard to use. So can we go to the next slide? Right. One of the issues with making any RF PCB is you need impedance matched tracks. In our case, 50 ohms input and output. There's a tool within KiCad for developing those tracks and understanding how wide they have to be, depending on the parameters of the board. Now, in this case, for 1.6mm FR4 PCB material, that's the standard really, you need about a 3mm wide track for 50 ohms. For 0.8mm with PCB, thickness PCB, it's 1.5mm. It's a lot easier to use a 1.5mm track than a 3mm track, for reasons I'll come on to. But if you think about the size of an SMA connector, that's part of the reason. Can we go on to the next slide, please? So here's the schematic. And I've pointed out the 50 ohm lines there that need to be of a particular width. There's not a lot to say really about it. There's an RF input, there's a blocking capacitor, there's the device itself, There's an output block, DC block capacitor, and the RF output. There's an inductor, which is to stop the bias. So the bias comes onto the output pin of the device. It's not got a separate supply voltage. To stop that interfering with the impedance of the line, you need an RF choke. That's what L1 is. The R1 51 ohm resistor, that's so you can run it off an 8-volt supply. You could also run it off a 12-volt supply, but you've got to remember that you'll be dissipating power in that resistor. Some of the devices you can also run off a 5-volt supply directly, but that's not recommended for this one, but you can do that with some of the other devices. Next slide, please. And here's the final result. So this is what I did, I think it was yesterday. I just put that together so you can see what the PCB might look like, and at that point I could say that's the end of the talk, but obviously it's not. So if we can now go to the screen share, I'm going to try and show you how I actually did all of this. Okay, so hopefully you can see that. When you open up KiCad for the first time and install it, this is the screen you get. And in this screen you can, so I have a project already here, the one that you were just looking at. We're not going to work with that one though, we're going to work with a new one. There are editors for schematic, for symbols, for PCBs, for footprints, a Gerber viewer. So the output of the program is typically a file for PCB manufacture that allows you to look at those files. Various image converters, calculator tools, ways for editing the drawing sheet, and plugins. And the plugins are a very interesting part of KiCad actually, because it adds extra functionality. Now I have quite a few plugins here, and some of which are going to interfere with this demo, but a particularly useful one is the one that produces the bill of materials, and if we get time I'll show you that in the demonstration. But so what we need to do is we go to File, New Project. So this is called BATC Demo. I'm going to call this Demo 2 for want of a better name, and that's it. We now have a demonstration. There's nothing in it, of course. It's just the three files here, which is generated automatically. And of course it opens it up in another window, so let me move it onto this and get it to fit on the screen. This is what you're presented with when you get into the schematic editor. So the first place to start is the schematic editor. And hopefully you can see that on my screen now. This is all about the hierarchy of the schematics. You can have different pages. I'm going to shut that down because I'm not using different pages. And I can edit the preferences and do the various setups. What I'm going to do on this one is I'm just going to leave it mostly to the defaults. So everything's set to defaults, apart from I'm going to import some settings from the previous project you saw, which is this one, I think. And the reason I'm doing that is hopefully, and you can see it now, actually it didn't do that, is the screen will get a little bit more easy to read. So I'm just trying to make the screen easier to read for you by using a slightly smaller sheet. Now, the first thing you've got to do with any project is give it a name. And in KiCad, there are a lot of keyboard shortcuts which you need to learn. You can do a lot of things with just using the mouse buttons, but not all of them. And in this case, I want to do something. I have to press the button E, and that brings up page settings. So I want to set this to A5, so that's a smaller one. I want to set an issue date. I want to set a revision. Let's call it 1. Let's call it a title, demo. And you can put all sorts of other things here, like, for example, your call sign or whatever you like. That'll give your sheet, your style sheet, a title and a call sign or a company name or whatever. You can add all sorts of things here if you want to. But let's go now back to the schematic. And this is where I need to reference that schematic. So let me just open that up on my other screen. Oops, wrong button. Sorry about that. Ignore that, Simon. Oh. The difficulties of trying to do two things at once. Right. What I'm trying to do is open up PowerPoint and the demonstration that you just saw. What I'm trying to do is look at this schematic to remind ourselves what we're trying to do. So you'll need to have that printed out on a piece of paper somewhere so that you can look at it. I'm going to move it to the other screen so you'll see me looking in various directions. Now, the first thing that you need to do is start to add the components. So it will open up various libraries and various things will happen. And hopefully at some point we will get a window coming up which will give us these libraries. There we go. Sorry it took a bit of time, but that's because I think I'm running a lot of things at the same time here. What I need is my Galley 59. So let's see if we can find it. There you go. So these are all the different devices, one of which is a Galley 59. I can now put that somewhere in the schematic window, like so. And that has put that in the schematic. Now there are some other parts I need to add, so I'm going to continue adding parts. The next part I think I'll add is the SMA. And there's actually two of these. And again, look through the library. At some point we will find the connectors. Here we go. Oh yes, coaxial connector, there we go. There are lots of these. I'm going to have to type more of it. Connector coaxial, there we go. Now, what do you notice about that? It's the wrong way round. There are various options you can do. If you right click, mirror vertically, mirror horizontally. We want to mirror horizontally. So there you go. Now we've got our connector on the schematic. And actually we want another one. So again, I'll click it and I'll click the same one. So now we've got two connectors. Coax 1, coax 2. So your input and your output. And then we need some capacitors. So again, in here, capacitor. And you'll get lots of choices, I'm afraid. Why did that not work? Hang on a second. C. There we go, C. Typed it too many times. So there's an unpolarized capacitor. Now, I don't know if you spotted that something came up about there being a no footprint. We'll come on to that in a minute. Now, another thing you can do, incidentally, is if you do a Control D on the keyboard, you can copy something. Just duplicate, which might be useful if you need two capacitors, say. And actually, we need three. If you hit the R button, it'll rotate it. So you can see what I'm doing here. I'm starting to build up that schematic. I now want to add something else, a resistor, which comes under R, resistor. Where's that going to go? Well, I think it needs to go roughly around here, so I'm going to need to rotate it again. And I'll put it there. And I also need an inductor, which surprisingly is called L. And I'll put that there. And then the last component we need out of all of these is the DC connector. So it's another connector. And we'll go for a generic connector, 2-pin. Doesn't really matter what it is, slightly different to the one I used before. And we'll put that, let's put that around about there. So now we've got all our bits of the circuit together. We need to wire them up, and this is where you need to go into this bit here, and you need to basically start connecting them. But there's one thing missing, and I don't know if anyone's spotted it yet, and it's not a component, so this is how you wire them together. Click on each of the dots, join the dots. Oops, missed that one. That's your schematic. But the thing we're missing here, and that's, by the way, how you join them together. We're missing ground. Now, in KiCad, power things are treated differently from components. Click on this add a power symbol here, and you're adding the parts. Comes under power, and if you scroll down, hopefully somewhere we'll find ground. That's your standard ground, and you attach that ground to all the things that you want to be grounded. And again, Control D for duplicate. Click on it, Control D. One there. We want one here. We want one here for the capacitor, and we want one here for the power supply. So that's now our schematic done in about 10 minutes. It's not that difficult to do, but there's a lot of things that are missing here, like all of the footprints. So that's what I'm going to talk about next. If I go to, for example, this device, and I hit the E button for edit, it comes up with this menu, and it shows a footprint already associated. That's because that part already exists. So that's okay. We've got a footprint for that one. If I go to the connector though, as you can see, there's nothing there. And that's where we need to click on here again, and another screen will open up. And this is where we do the connectors. And sorry for the slightly difficult to read because I've got all this on a large screen so you can see it on the stream. We need to choose a footprint and connectors. But there's lots of connectors. And down here somewhere is the RF connectors. But there's also connectors via different companies. So these are the libraries that come as standard. You can generate your own libraries. I don't really have time to go into that. But let's go to connectors coaxial. Now we could choose a BNC connector. We could choose MMCX. I'm going to choose SMA, vertical. So double click on that. Okay, we've now got a connector. If I go to the other one, again, same thing, use the same connector. Then we come to capacitors. We need a footprint for the capacitor. Now, again, capacitors are typically using Surface mount 0805 is the typical number. You could theoretically use a through-hole capacitor, but they're getting hard to find, and they also don't work as well RF-wise. So we really do need to start to use capacitors that are SMD. So if I now start typing capacitor here, hopefully capacitors SMD, it will come up with a huge list of potential capacitors. And you have to look through this until you find the one you want. Now you can actually type in 0805 because that's the package that we're using, and you just start off and it will come with all of these. Now 0603, 0805, that's come up because it's got the 08 there for the imperial, the metric numbering. I will click on this one. The standard 0805 looks like this, but KiCad has a rather nice one that's designed for hand soldering, so the pads are a little bit bigger. So I'm going to click on that, and there you go, that's there. Now I could go through all these menus again to do all these other ones, but what I'm going to do actually is a shortcut here. You can copy that, because you know you're going to be using the same capacitor here from the parts list, and the footprint, you can just paste it. So that makes it a lot easier. And actually there is a way of bulk editing all of these things if you wanted to. One of the icons at the top, that's bulk editing the fields of all the symbols in the schematic. So that can be a useful way to shortcut all of these things. If we then go to the resistor, we need a footprint for the resistor. Now again, these will be in here. So resistor, SMD, oh sorry, that was relay. Resistor SMD. Now I don't know if you remember from the schematic in the PowerPoint, because I didn't dwell on this, but the power rating of that resistor needs to be about 1/4 watt, which is quite a lot for an 0805. So the solution to that is use a bigger one, and in this case we're going to use a 2512. So we look through this list until we get to 2512. Again, hand solder. We select that footprint, OK, and then we come on to this one, the inductor. Again, we need to choose a footprint. And it'll be a lot easier when you're doing it because it won't be appearing on 2 screens. But inductor, SMD. Now the particular package for the one that I found in Mouser, which was a 470 nanohenry capacitor with a resonant frequency, a self-resonant frequency in 70 sems, which is what you want for an amplifier that might work around 70 sems, incidentally. That comes in the SMD 1008 package. And there we go. And again, choose the hand solder one. That's that. Now the only component I think we haven't done is this one, the connector. We can select that in the same way. And I'm going to use a Molex connector, and I'm going to use a Molex KK254 connector, and in fact I'm going to use this one, which is a standard 2-pin Molex. Whatever your preferred connector is, use that. And at that point, hopefully, and I will save this now, we've got our schematic more or less done, except for a slight, well, fairly obvious missing thing is we haven't actually got any values. So I'll just fill these in. This one, 1 nanofarad. The resistor, Again, I'm pressing E, incidentally, to select this particular thing. What did we say that was? We said that was 51 ohms. I don't actually need to put in any values, but it helps with the bill of materials. This capacitor, 1 nanofarad again. And this capacitor, that was 100 nanofarads. Oops, I selected the wrong thing there. Sorry. There we go, 100 nanofarads. And the inductor, 470 nanohenries. So now we've got our schematic, which hopefully looks rather similar to the one in the slide that I showed at the start. And just to show that, if I can persuade this thing to work, I'll move this over. There we go. I don't know if you can see the similarities here. So we built that circuit. No, I haven't put it there yet. There you go. Can you see it now?
That's fine, Mike. Thank you. Yes, I was just saying we couldn't see it at home. And
yeah, it's a feature of Zoom, isn't it? That unless you actually
the window, but that's fine. No, we can see that fine. So that was the original schematic, and you've recreated that on the KiCad.
Yes, it's good to get feedback actually, Dave. Thanks for that.
That's all right.
Now, there are various things to check here that you can do. You can, so we can, for example, fill in it automatically labels parts, starting from 1, so R1, R2, C1, C2. You could actually open up a window to do that if you want, and redo them. This, incidentally, this won't appear in your normal, this is a plugin, so ignore that one, but this one is particularly important. This is the footprint assignment tool. Now, I did this manually, but you can actually do that in this tool. So all our devices have footprints. You can also generate a bill of materials if you like. But the one I think we want to do is this one. But before we do any of that, I think we need to check whether it's all okay. And we could perform what's called an electrical rules check. Now, in my case, this will come up with some errors. Those errors are all about the simulation. So we can ignore all of these. And in fact, if you want to, you could say, right-click, exclude this violation. Exclude this violation. Ignore all spice. Right, try again. And now it's quite happy. Now, you quite often get this thing about no power. This is again to do with the simulation. Don't worry about it for the moment. It doesn't really matter. There is a way to fix that by using a thing called a power flag, which will come up here. This one. If you put that somewhere around, this just tells KiCad where the power comes from for when it's doing its electrical checks. But it doesn't really have any bearing on your PCB design. It only really becomes important when you're doing a simulation, which is a bit more advanced. So we got to this stage where we've got a schematic. Now we need to design a PCB. And this takes a long time because you want to make it look nice. But the first thing to do then is to click on this icon here. And let me just bring this into the window. Hopefully that's visible. You have a blank canvas in the PCB design tool. That's all very nice, but the first thing you probably want is your components. So on one of these icons, update PCB with changes made to the schematic. Click on that. And hopefully, there we go. Thank you, Dave. Right, so we're about halfway through, so let me speed up a little bit. Here are all the components that KiCad has got from the schematic and put the footprints on. What do you do with them? Well, you just put them somewhere for the moment, because the first thing you're going to need to do is design, put them on a board, and you've got to think about layout and also how big you want the board to be, and that depends on what sort of box you want to put it in. And you might want mounting holes, you might not. If you wanted a mounting hole, for example, and let me just show you how you do that. You go back to the schematic. Mounting hole is treated just like any other component. Mounting hole with connection, mounting hole without connection. Let's do one without. There you go. We now have a mounting hole. And again, that'll need a footprint. And that footprint, for example, how big do you want your hole to be? M3, for example. So let's double click that. Now we have a mounting hole. Now we probably want, oops, sorry about that. We probably want more than one mounting hole actually. So what you can do, and this is a useful shortcut, is again, Control D to duplicate, Control D to duplicate, Control D to duplicate. If you do the duplication after you've assigned the footprint, and I'll show you on this one, the footprint will already be there. So that's rather useful. So what's happened now, we've added something to our schematic. But that's not reflected in our PCB yet. Click on this icon, update PCB from schematic, close. Here are our 4 mounting holes. So you can switch back and forth between the PCB and the schematic, and that's very useful if, for example, you want to change something. You might want to swap some pins on a component to help with the routing. So here we are. Now the first thing to do is to work out roughly how big it is, and if you want to manufacture a PCB, you need to have a defined rectangle, and it's on a set called edge cuts, a layer called edge cuts. This is part of the Gerber files. If I create this like this, there we go. Sorry. Nice sort of size to choose. Incidentally, I've set the grid to metric. I can show you how to do that, but it's quite simple. Right click. There you go, 40 by 40 millimeter PCB. Now, there are lots of keyboard shortcuts you need to get familiar with. M for move. It would seem logical to put our holes in the corner. As a first start. And then we need to zoom in a bit, I think, because, and you zoom in with the mouse wheel incidentally, because look, they're not quite right, are they? So let's move that. Well, I've set the grid to 0.5 millimeter. So it moves in defined positions. You can set a finer grid, but then it's harder to set something exactly in place. You can also edit it and edit the exact placing if you want. Now J2, this is the output, so I'm going to move and put it here. Now you may be wondering why I'm putting the output where normally you would put the input, but it's to do with the way the device is organized. And I'm going to put other one here. I'm going to put the 2-pin connector there, and then I'm going to look at the device, this one here, and I'm going to move that And I'm going to, you see these lines that are moving between, those are the connections. Those are what we call the nets. And they say what's connected to what. So I'm going to put that there for the moment because that's about where I think it needs to go. C1, the input capacitor. Where's that got to go? Well, that goes with J1. C2, the output capacitor, blocking capacitor. That goes with the output. Let's put it there. The resistor, well, that's going to be somewhere around the DC supply. I'm going to put it somewhere around here. The inductor, I'm going to put it somewhere around here. And the bypass capacitor, I'm going to put it somewhere around here near the connector as well. So that's got all our bits roughly where we might want to see them. How are we doing for time? Okay, we're okay. And now I'm going to zoom in a bit more. And I'm going to move that around. And this is when I now have to start thinking about how I'm going to route this board. And I've also got to bear in mind that we have particular widths of components. So what would be a suitable track width to use? And this doesn't really show up very well, but I'm going to edit the sizes. Hopefully. There we go. And I'm going to add some track width. So there's a predefined size which is 1/4 millimeter. It's a bit small there. I'm going to add a 1 millimeter. And I'm going to add a 1.5 millimeters. So those are the tracks that I think would be about right. And the reason I'm using quite wide tracks is quite often you might actually want to, well, maybe not so much nowadays, but in the old days you might want to hand etch this. So using very fine tracks is not easy. Now I don't know how well they're going to be showing up these nets on the screen, but these little wires indicate what's connected to what.
I think they're very faint actually to us, so they may be even fainter to everybody at home. But,
yeah.
But that's okay. If everybody at home, if you just look between, for example, as you say, the Galley 59 and straight above it, the Con 01, there's a sort of very fine white or grey line between them.
Yeah.
But I just thought I'd elaborate for people watching at home. Thanks, Mike.
Yeah. So all the nets appear in this table here, and so we have ground, for example, we have what's connected to J1, and we can also turn on and off different parts of the diagram. So I find the thing saying mounting hole, for example, that is a fabrication layer. Don't really need to know that at this stage, so I can turn those off and it makes the thing look a lot cleaner, so you can see what you're doing. And apologies that you can't actually see these nets, but when we come to wire things up, then it'll become fairly obvious. So let's try doing that. So routing tracks, this tool here allows you to route a track, and I'm going to look at this one here. So I'm going to connect this capacitor up, and now it's highlighted the net, and you can see it's using a very fine net. If I hit the W button, I can use a wider track. There we go. So now we've done that. We've wired that capacitor up to the connector, and that's the bypass capacitor. Now there was also another thing here, which was the resistor. Now then we have the inductor. There you go. Now this is not necessarily the best way to route this, but in the interest of time I'm not going to finesse it. Those are the sort of the DC tracks, apart from then the connection between the inductor and the output of the mod amp. I'm going to turn off the routing. I'm going to go away from the routing of the tracks now and just talk about how we might do the 50 ohm line. Now, you may remember I said at the beginning the 50 ohm line is 1.5 millimeters. So for the capacitors, certainly I can just route like so. Oh, but look, that's not going to work, is it? That doesn't look right. So what I need to do is I need to select this capacitor and turn it round. So now it looks a lot better. There we go. Now where is that going to? It's going to pin 3 here. But there are particular requirements for these devices, and if we have, well, we've got a little bit of time. I'm not going to go into great detail here, but
we haven't got too many questions so far, Mike. So
No,
please
okay.
carry on. I think I'll
Yep.
be speaking for everybody and thinking we're intrigued, and we'd like to see you complete
Yeah.
this if you can.
Yeah, so what I'm going to do is I'm going to do a thing called add a filled zone. So that adds a zone, as in a PCB material, that you can draw a graphic. So what I want to do is draw a 50 ohm line. So I want to draw something that looks about 1.5 millimeters wide. Now actually I think that one that I've got here, this one, is not 1.5 millimeters wide. I think that is 1.5 millimeters wide, and there's a little bit of an overlap on the capacitor here, but it doesn't really matter when you do that. But when you come to this one, it'll look a bit strange. So we're going to put in a filled zone, and what I'm going to do is I'm going to start it around here, halfway along the capacitor, and it wants to know, oops, hang on a minute, sorry, I need to choose the layer, the front, let's try again, front copper. Right, what net is it connected to? Well, it's connected to C2 pad 1. I don't want thermal release, I want it to be solid. I'll leave everything else at the default. So now I'm going to draw something that's about 1.5 millimeters.
Mike, could you just briefly tell us what thermal reliefs meant?
Yeah, so thermal reliefs are when you have something that's connected to a big ground plane and you try and solder to it. It's very difficult to get the heat into the soldering iron. So thermal reliefs are little sort of bits. In fact, I can show you it once I've done this. So
Okay.
Anyway, first of all, and I'm just going to make those zones a bit more visible. That zone is now there, and what I can do is I can fill that zone using one of the which is this one here. Oops, no, that's the wrong one. Well, let me go on to doing that. Let's try it again. It came up with the instructions here. B. There we go. So the KiCad shortcut for filling a zone is B, and I don't know if you can see that we've now got that zone, and that looks just like a track, and that's connected those together. But let me zoom out a minute and just show you the thermal reliefs issue, because that's quite an interesting one. What we would have on these PCBs normally is a ground plane on the back, and we do that with the filled zone. So we select the filled zone. We want it on the back copper, and we want to fill up. We want it connected to ground, and I'm going to leave thermal reliefs in, and you'll see what happens. So that goes to there. Draw that in. There we go. Fill that zone up. Now, can you see what's happened here around the SMA connector? We've got little sort of things. They are thermal reliefs. So that's what a thermal relief is.
And that makes it easier to solder in this
Yes.
case, the connector, the metal bit of the SMA. Well, I'm sure we've all tried to solder at some point a giant piece of copper on a piece of on a circuit board, the back of a circuit board, and of course a lot of it takes all the heat away. So that's what those do?
Yes, exactly.
Thank you.
Right, so let's go back to our board design. We've still got a few things we need to do. incidentally, those do make the ground connections now, which is what we want, so that's fine. Again, like other things, you can copy and paste, but if you do that, you've got to remember that you'll need to edit it because it'll be connected to the wrong thing. I'm just going to copy and paste that, and I'm going to put another one. I'll put it there, and then I'm going to edit it, and I'm going to say what it should be connected to. In this case, it's C1 pad 2, because C1 is there. Now that's going to look a little bit strange, isn't it? Because this capacitor, I think, is also the wrong way around. So we need to rotate it like that.
Is that quite easy what you're doing there, Mike, with the mouse,
yes,
presumably, to rotate? Okay.
It's not the mouse, it's the keyboard.
Is it?
You hit the button R to rotate right, and I think L to rotate left. Again, you need to learn these things, but it's not too difficult. You can also do it with the mouse. So let me show you. It will come up with, if you right click on it, it'll come up with this menu for doing things, and you have to select the whole thing.
So like all software, when you get used to it, the shortcuts can help you get around.
And actually, over here we have a selection filter. So if I select nothing, I can't select anything, but I could say just select footprints. And then when I try to select a track, it won't select a track. If I select footprint, it will select a footprint, and that's really useful because especially when you've got lots of things on top of each other, just connecting the things you want. And in fact, if I turn off zones, for example, I can no longer select these zones, and I've finished with those for the moment. So, that would be good. Now you see I've selected the zone, and it's or I select that zone. What I want to do now, though, is I want to do another track, which would go from here, and I'm going to press the W button to select the wider version. That is my other track. Now, I don't think that's exactly the right width, but we're not going to bother about that now. I'm just going to come on, because of the time, onto the device itself, because that will need connections to ground. And the way, if you look at the data sheet, the way that has to be done is specified. And again, it's another one of these filled zones that I'm going to use here. And this is specific to RF. So what I'm going to do is I'm going to create a big zone covering most of the board on the top copper that is also connected to ground. So I'm going to go here, ground, OK. Now the reason I'm doing this is partly for RF purposes, but really because I want to be able to cool the device. And if you have a large area of PCB copper, it helps to reduce the heat dissipation. So there we are. We've got that zone there now. Let's go back to our device. Now that is all connected, and KiCad is quite happy with that, but actually we want a via, and if you want to add a via, you use this tool for adding vias. It's always a good idea to have quite a lot of vias in your RF circuit.
Forgive me elaborating on this, Mike, but it's just that a via is a term. If nobody's designed a circuit board, I'm sure everybody will have seen a via, which is really a hole that usually connects the top layer to the bottom with plating through the hole. I just thought I'd explain that for anybody watching this sort of thing for the first time. Thank you.
Yep, that's very useful. Thank you, David. Yes, we'll put one here as well. So we've got lots of vias which are connecting top to bottom of the board. So that has now grounded everything. Now we also need a via here for this capacitor, C3, because it's connected to ground. So there we go. Now there's one track missing, which is between L1 and here. I am going to go for the very narrow track here. Oops, like that. The reason I went for a very narrow track is it maximizes the inductance. This device only takes 65 milliamps, so the thickness of the track really doesn't matter. But at that point we've got our PCB designed. So there it is. And we can run a thing called a design rules check. Now that will come up with some errors. And the errors it will come up with are things like logos are off the board. So if you want to move text, you move it, you select it, you move it. So click on it, move it. Don't think we really need to label holes, and in fact, if you don't want to label a hole, you can edit it. So you can edit the properties and you can make it invisible. So we're not labeling our holes. Now, I don't know if you saw that I accidentally selected the bottom layer there when I clicked. So this is where this selection comes in. If I just want to select text, it makes it a lot easier, because now it won't select, it'll only select the text. I can make that non-visible. There's another one here hiding. And that just makes your board look a bit nicer. Now you can add text as well, but we've basically got a board here now, and we can do a check. So this window is a design rules checker. Going to run that, run design rules checker. Hurrah, no errors. There you go. So that's our board. All done. Now, one of the nice features of KiCad is it's got a 3D viewer. So if I click here, click on 3D viewer, it'll open up on the wrong screen again, but let me just pull it over. That gives you a 3D visualization of your PCB. Now, what you notice is the connectors are not in there, and that's because it doesn't have a 3D model of the connector. There's a way to fix that, and I can show that, but it'd probably take a bit more time, and it involves finding a 3D model of the connector and inserting it into the footprint file, and there's a tool to do that.
And if you found that from a library somewhere and you put that into your KiCad, you wouldn't have to go to find it again, is that right?
Yes, you'd store it in your library. And in fact, at this point, we do the Blue Peter bit, and we shut this down, and we shut all of this down, and we open a recent project. Here's one I did earlier. So there you go. It looks similar. I did a bit of practice. And if you now do a 3D view of that one, you'll see I did actually put the connectors in. But what I want to do is actually move on to the final bit in the last few minutes, which is around what you do with these things. So let's open up the PCB, because you want to order one, yeah? You want to get one from the shop. And you can get plugins for various shops that will actually allow you to do this. But what I generally do is I make some Gerber files. So Gerber files are what you have to send to the PCB house. And the way you do that is plot. Now, the default values of this are generally okay for a lot of the Chinese PCB houses, which is good, because it means you don't have to fiddle around with any of these settings. But in some cases you will, but they'll have information on the website is what you need to set here. Now I'm going to put these in a directory, and there isn't a directory there at the moment, so I'm going to create a new folder, and I'm going to call it Gerbers, and I'm going to select that directory, and I'm going to plot the Gerber files. It wants to redo the zones first, which is fair enough, so it'll do that. It's very important that you also click on generate drill files for the holes. So generate a drill file, generate a map file, close, and then close these off. It's now created all the files in the Gerber file, in the Gerber folder. And if you were to go and look at that folder, so let me just, save this. Let me put that down. There is a Gerber viewer here, and the Gerber viewer allows you to look at those files. So you can open Gerber files, and I'm going to have to select. So where do we put it? We put it in here in Gerbers. So we got front copper, sorry, back copper, front copper, edge cuts, solder masks, all these things. So let's look at the front copper. So that's the tracks basically. If I open that up in the Gerber viewer, that is what you would get in your copper top layer, and you can see where all the parts to put everything is.
So this is what the PCB manufacturer needs to be able to make the different layers and everything else of the circuit board. You don't need to worry about it too much because it creates those all for you.
Exactly, yes. So, but we can go further than that. We can go to JLC PCB, which I'm just opening up. I don't know if you can see that.
No, we can't see it at the moment.
Okay.
Oh, there we are. Now we can see it. Yes, that's fine.
So I would like to do this. You click on this Add Gerber file. So what you do is you find those files in the directory that you stored them. You put them into a zip file, and you add that Gerber file into there, and then you select what you want. So it will read the Gerber files, and it will work out the dimensions, how many you want, what sort of PCB thickness. So in this case, remember, it's 0.8 because we wanted those 50 ohm lines. Of course, we want it to be purple.
That's added a lot to the price there, I noticed, Mike. That went up from £1.64 to just under £15. So
exactly,
keep it standard if you don't want to spend a lot more, I guess.
Indeed. So if you want it in a colour at 0.8 millimeters, it's going to cost you more.
And I believe, just for people wondering why that would be, it's because most standard one will be green, and they make these circuit boards so cheaply. One of the reasons is, apart from it being in the Far East, is that they make it as one massive sheet every day, say, and then they cut it up for individual customers, isn't it? And they probably have to maybe do much smaller runs of other colours. Is that fair?
That's right. So if we go to the 1.6 millimeter, which is much more common, you see that's the same price. If I now select purple, it doesn't increase the price because they make a lot more of those.
Oh, I see. Okay.
Yeah. So it's only because it's 0.8 that there's a special
yeah.
process fee.
So they might have to put a special run on. Yeah.
Exactly. Yeah.
It's still a fraction of what it used to be, isn't it? When I was in business and buying circuit boards, prototypes cost an absolute fortune. You know, about £100 roughly for a panel.
Yeah. But look at this, £1.64.
Yeah, incredible.
You save that to the cart, and when you go to the shipping, you want to use the global shipping line. The whole thing will cost probably about £5. So it's remarkably cheap, but you have to wait 2 or 3 weeks. If you want to get it fast, it costs you more. 24 hours costs you more, and if you want to get it by DHL, £20-30.
Yes,
you know, sometimes you need to do that.
Yeah.
So that's basically how you order a PCB.
Absolutely fantastic. Well,
right. Now
we've rushed through those things. I don't know. It's amazing that you've done that in an hour. Really, shown us from nothing how to do it. Got a few little questions. We've got a couple from others, and also I've got a couple which I think are quite important. KiCad, how much does it cost?
Nothing. It's
wow. Free. Okay.
So donations, of course, if you want to donate.
Yeah. Does it just work on Windows, or will it work on Mac and Linux, or?
It'll work on Linux. It'll work on Mac, but you're going to have trouble because you haven't got a right button. So I don't know what you do on a Mac when you haven't got a right button. It'll work on most types of.
Actually, if you use a Mac with a mouse with 2 buttons, it does sort of work on a Mac, but I know they don't use it.
Okay.
But thank you for that. Now, I've got a question. I do want to get this in. Sorry, Mike, we are pushing for time now. So a quick question for you from Tim, M0KEP. Why use a fill zone instead of a 1.5 millimeter track for the 50 ohm lines?
Right, well, that's easy. So that's the bill of materials, incidentally. If you come and look at this very closely, let me zoom right in. Can you see how that's rounded around that capacitor?
Yeah.
That should really be a fill zone. It doesn't matter there, but when we get to here, to the device, if that was rounded, it would get too close to the next pin.
Right. So that makes good sense.
But you can. It just doesn't look very nice, really. And there's specific advice as to how you should do, where you should put the wires and things around these devices to get the best performance out of them. They work to 6 to 8 gigahertz, but. Okay,
that's brilliant. I want to try and get through these questions, if I can. G4SAQ Russ says, is there a maximum board size for the free version, Mike?
Well, I'm sure there is, but it wouldn't make any difference if you paid for it. How much memory have you got? So
they haven't got a limit because it's free, and then you have to pay if it's bigger, no?
No, I mean there's a maximum size that the PCB house could create, of course, and the number it does multiple layers instantly. You don't just have to have 2 layers. You could have 3 layers, 10 layers, whatever. It does all of that.
Okay.
And you can have vias in between layers and in between internal layers, all the normal stuff that you get with a paid-for package. It's very good actually, and it's been supported by CERN, which means it's got reasonable development capability.
Yeah, it's really good. And I see that just looking at doing a little bit of homework before your talk, you know, it even imports schematics from programs like Eagle, Altium, and CADStar. So if you use something else,
I've done that.
And I guess you could design your circuit from the first place on KiCad then.
Oh yes, that's what I normally do actually, because I find it easier to draw the schematic. And if you want to move, you know, pins around and things, then that's very easy to do on KiCad. It's a lot harder to do on a piece of paper because you have to start rubbing things out and redrawing them and things.
Absolutely. And by the way, Noel G8GTZ has added on there that Mike designs the BATC PCBs and then emails him the Gerber files, and then he orders them in blue with DHL delivery from PCB Way. So that's how we get them quite quickly. Mike, thank you. Oh, I've got one other question. Julian Baldwin has asked, are there any other UK producers to avoid using the Far East? And well, I'll let you answer that.
Yes.
And but they cost quite a lot more, don't they?
Yes, they do. Newbury Electronics used to be the one that we used professionally. I don't know if they still exist. I mean, the other thing is if you want to get a board for, say, a satellite, I know that David G0MRF does that when he's building CubeSats or FunCubes. You want to go to a proper professional PCB house with traceable things.
It is, and
for just knocking something up for amateur use, these are very, very cheap.
I think I agree with you. I mean, it's and I'm as patriotic as others, and I try and buy British, and we used to buy British circuit boards for production actually from a company called Minitron in Kent, and they do offer a reasonably priced prototype service. However, it's still around £80-90, something like that, to buy one-offs, and if you're a hobbyist, you know, that's probably a lot for just to try something out. So that's why these firms, they do come in. And the thing is also fair to say, Mike, as well, if you order quite a lot, then the price actually goes up, doesn't it? They do specialise in just producing small runs.
Yeah, they will do bigger runs, and it does work out cheaper, but usually it's a specialist. The other thing to note, by the way, is a lot of the Chinese houses have a size limit, and if it's more than 100 millimetres square, it costs more.
Yes.
They add a $7 Euro engineering fee or something. So yeah, but I mean, I've had boards that have cost £4 delivered.
Yes, it's extraordinary.
For 5. It's ridiculously cheap.
Great, Mike. Thank you very much indeed for today's talk and doing this live. As Michael EA7KIR says, it was extremely brave of you to do this live, and I echo that, and everybody does. I'm sure we all appreciate this. And I'm sure it's also, by the way, this is all going up on YouTube as well as the BATC line. So if you're watching on YouTube, or if you look afterwards, within a day or so, this will all be up there to replay. So if you are going to have a go at KiCad and you haven't done so already, you know, you'll better rewatch this on there. Mike, thank you ever so much for this demonstration. I'm sure it's inspired many of us to give circuit board design a go. I started way back in the late 70s and 80s, and at that time we were using red and blue tape on clear acetate to make circuit boards. So it's moved on quite a lot, and to think that this software is free is wonderful. Thank you ever so much.
We used to use pens, didn't we?
Oh yes, pens as well. Absolutely. and crepe tape. My very first ones that I used to etch myself as a kid. Anyway, many thanks for your demonstration today, and also thanks for all the work that you do for designing circuit boards for the club.
Okay, thank you, David.
Thank you very much, Mike. We're just going to take a very short break now. So we're going to get Dave back on the line. He's going to talk about the latest update on replacing the Serrit tuner for Ryde. Back in a moment. welcome back. Sorry, we're running just a tiny bit late, but I thought it was really important to take those questions and have a wrap up with Mike's talk on circuit boards. Brilliant talk. Now, Dave G8GKQ really needs little introduction to us all, I'm sure, as he's been a very active member of BATC for a long time and has led the BATC port stand project for 7 years now. He's also held many roles in the club, including chairman, and he's currently our treasurer. Here he is today to talk about the loss of a key component in modern ATV, the Serrit tuner, whose stocks are now exhausted and we need to find a new solution. As always, please feel free to ask questions and make comments using BATC messaging or YouTube chat anytime during Dave's presentation, and I'll read them to him at the end. So welcome to you, Dave. We can't hear you, I believe. Or can we?
Oh, good.
Oh, right, that's okay. I wasn't hearing you in my earpiece. Sorry, that was my fault.
No problem. Thank you very much, David, and thanks to everybody else who's presented so far. Right, I'm just going to start up the slideshow because I'm having some issues here. And if I do that, and then, hang on.
We should just explain, this is a hot seat changeover, we used to call it in the Beeb. Where you literally have taken over, although you're miles away, I'm sure, from Mike. But
right,
you know,
okay.
I can buy you a little bit of time if you like by going.
No,
through the
that's
program.
right. Hopefully you now have my slides up.
I think so. Just ask Tammy. Yep, we've got those. Fine, thank you.
Brilliant. Okay, excellent. My apologies. I've up until 2 minutes ago I was transmitting on QO100, and that was the hottest part of the changeover. So right. I'm going to talk about replacing the mini tuner. As you know, we've run out, having ordered 400 in our last order, and we should actually have ordered more, but can't win them all. So what I'm going to talk about is why we need to replace it, some initial thoughts, have a look at the promising options, and what next. Now, we haven't sat idle on this. The picture there is of one of the candidate tuners we looked at before we got to this stage, and I'll talk a bit more about that in a moment. The FTS 4334 and 4335, they're both essentially the same tuner that we've used now for about 4 or 5 years, one with a preamp, one without. We think it was it's specifically built really for test equipment. So it wasn't a large, it's never been in large production, and production has now ceased. We thought the ICs that were used in it were no longer available, but we now think we might be able to get hold of some. But there appears to be no simple replacement on the market. So our initial thoughts, and I put out a paper about this on the forum about 2 weeks ago, was could we use new software with an existing tuner, say, for example, the one I just showed? Or should we build a new tuner with new software? Or could we use an SDR or tuner chip with a custom FPGA and some new software? Or can we do it all with a software-defined radio and custom software on a PC, or even, and this came up during the process, the Raspberry Pi 5? Since I put out the paper, we've found that the ICs in the existing tuner, the FTS 4334, 4335, may still be available. So we're investigating that. The SI266D is a demodulator IC, and that's used in the SF808, a commercial satellite receiver that does do reduced bandwidth, and that seems to be easily available. And people have commented that they have used SDR Angel, which is usable but quite fiddly. So we're looking at investigations. Can we source chips and build perhaps an FTS 434 lookalike? Or how practical is it to use the SI266? Or perhaps could we get a more usable version of SDR Angel? Let's go into details on each of those. If we were able to get the STV 6120 and STV 0910, that's the tuner and demodulator chips for the FTS 434, we would probably put them on a single PCB with a surface mount 74HC10, just as like is in the conventional tuner, the current tuner. And we'd probably, instead of using the USB module, we'd put the USB chip on the board with the power supply on the board and possibly some amplifiers on the front end. Now, of course, the amplifiers used in the original tuner were custom or seem to be fairly special to type amplifiers that are actually controlled by software for their gain in the version of the tuner that had the preamps in, but they're not essential. So that's one line of investigation, and that hinges on probably three things. Can we get the STV 6120? Can we get the STV 0910? And can we get a PCB made up for it? The STV 0910 is quite a challenging chip to mount on a PCB. If you think what Mike has just demoed, we're talking about a chip with 160 connections. So we've got some challenges there if we do that. A second option, this came out of discussions really with Martin M0LNG last weekend, would be to use the SI266D, and he's proposed this very comprehensive solution. We'd use an RFFC 5072, which is a PLL and mixer chip on the front end. Now he has experience of using this on the Hack RF, and that will give us a possible input range of anything from 1 to 6,000 megs. We then need to have a 0IF tuner. We'd use a conventional satellite one like the Max 2120 that's easily available. And then use the SI2166D for demodulation, and then go into our normal FT2232. So that is another solution we have under investigation. The disadvantage of that compared with the let's build a substitute for the previous tuner is that we would also need to amend all the long-min, Ryde and Portsdown software and Open Tuner software to work with this. And of course it would not work with the Windows Mini Tuner software. However, the advantage is longevity of supply of the chips. The third option we're giving serious consideration to is a version of SDR Angel that works really well for DATV. I'm getting mixed messages on whether a Raspberry Pi 5 is going to be up to the job. Some people say it will, some people say it won't. Certainly a Raspberry Pi 4 won't be. Could do it on a high-end PC. Then we have to look, are we limiting ourselves to Windows, or is there a Linux solution to this? Currently, I'm aware SDR Angel, you need to set the FEC. Now, that's not particularly convenient for QO100, where you don't really know what somebody's FEC is until you look at their signal. And the last thing we want to look at is there a performance penalty for using software? Currently, people have done trials. It's 1 to 2 dB worse using a software designed, a software decoder than using the hardware decoder. But we need to go into that with our eyes open. So what are we doing at the moment? It's early days, but we are checking the availability of supply of all these chips. Having a think about the performance issues. One of the things I'm personally worried about is that how well does the SF8008 tuner, we're lucky in that we can test this new IC in an existing setup. How well does it work in the presence of adjacent signals? That was a problem we had with the old Sharp tuner when we came to use it on QO100. It didn't handle adjacent equal level or stronger signals very well. So we need to look at that to make sure we do come up with a solution that is practical. We need to estimate the costs. Are these chips too expensive to buy? How much will the PCBs cost to fabricate? And clearly, as we're using surface mount, we're going to get somebody to put these boards together for us. What is the cost going to be? Now, when you think that 4 years ago we were paying £100 more or less for the Portsdown filter modulator board, which had a lot cheaper silicon on it and was a lot less complex, the cost could be significant if we're not careful. And then lastly, what's a credible manufacture and sales model for BATC? Who takes care of boards that don't work when they've been built? Who bears the cost of that? How do we do returns for people who have problems with boards? How much risk do we put the club to financially? So there are a number of issues to look at there before we just go out, do a KiCad design and get a fab house to build it for us. But anyway, that activity is all ongoing. And I just wanted really to give this update of where we'd got to and let you know that there is an awful lot going on behind the scenes trying to solve the issue. So with that, David, I'm ready to take any questions that people have.
Okay, Dave, thanks very much. Yes, and I, doing my homework for this, again, looking at that, you've got a 4-page comprehensive document covering a lot of the challenges, haven't you, about this replacing it. So if you didn't catch everything that Dave said and you want to look at it in more detail, that's available on the forum. I think I downloaded that from BATC forum.
Correct.
So please look.
Yeah.
We've had a few bits of feedback, but this is a great time for you to let us know what you think as well. And I'll start with someone we know very well, Everest F5 OEO. So if SI2166D not compatible with old software, not need the FT2232, as we could use Raspberry Pi Pico over Ethernet. That's a Brian project, he says, and I guess that doesn't mean anything to me, but maybe to you, Dave.
Yeah, it does. We need to look at how much we redesign at one stage, I think, Everest. I agree, a Raspberry Pi Pico could substitute for the FT2232 as an interface option. But if we are going to have a solution that works across all the existing receivers, the minimum amount of change that we can introduce, the better. If we were starting from scratch, Raspberry Pi Pico is definitely the way to go there. So that is another thing we are looking at, but we've got to take into account the whole software stack and future support of that software stack as well. Yeah. Thanks, Everest.
And I think that chip, that converts basically serial to USB, doesn't it?
Well, in fact, what we use it for is to convert parallel to USB, okay. And also to do the control channel back to the tuner.
Yeah, we've got to bear in mind. Sorry.
There's no reason we can't do that using a Raspberry Pi Pico and Ethernet. But the moment you introduce Ethernet into the equation, it's something you just can't plug into the side of a Portsdown.
No, and also drivers for the various chips, because the FT2232 series I know is well supported by drivers for most platforms. But again, that would complex that, and I'm sure we all appreciate all the work that you and everybody is doing on this. But it is a great time, everybody, now, if you're involved and interested in this project, to sort of have some input now. By the way, Everest also added, chips should have an option to receive BB frame, brackets, not only the transport stream.
Yeah, I suggest that's a nice to have. Most people want to watch TV, but it would be great to be able to enable the further experimentation that Everest wants to do. Sure.
Okay. Have we got any other questions from the community? I'm just having a look now. Mike G0MJW says, we are amateurs, so do we take a risk with construction? I think what you're suggesting is that at least some of the SM chips should be pre-soldered on, probably by a specialist assembly house.
Yeah, the problem is that if these chips had leads coming out of the side, I would agree, but they're actually ball grid array chips, so they need to be reflow soldered on. So I think that's beyond a lot of most amateur capabilities, certainly beyond mine.
Yeah, Dave actually, just at the same time as I asked it, Dave M5 TXJ asked the same thing, perhaps a PCB with the surface mount TV mounted. Corn ON70MOR says, why not use Pluto Lima Mini for receive?
That's fine, but it doesn't do the decode of the signal. The thing that's different about digital ATV is the error correction. We can get down to resolving the constellation using a Lime or a Pluto simply, but then you need to go through the apply the forward error correction, and that's why in the software solutions, for example, you need an i9 class PC to do that error correction, or you need an FPGA or an ASIC, and that's the thing we're trying to replace. So that's the very difficult bit. I will just come back to PCBs. The other thing we have to consider with the PCB is if we do sell a partially populated PCB, where does the responsibility lie for, oh, this doesn't work? Is it the constructor we've sold it to who bears that responsibility, or will he come back to us and say, oh, the chip wasn't soldered on properly? So the moment you start selling these things, as opposed to doing it as just a small group of amateurs, things are a lot more difficult.
Yeah, I can appreciate that. And this is quite a lot of outgoing, potentially, I presume. You'd probably, I mean, from my knowledge of it, you'd need to order something, at least 100 of something like this to make it viable for a contract manufacturer to set up and producing. So from what you've said already, this is, we're into thousands of pounds, aren't we, of investment. So this is the club's money, which I guess is all of us as members' money. So yeah, this takes some thinking about. Jen G4HIZ says, would the original manufacturer allow a third party to use the design under license?
We don't know. We are contacting them to ask.
Okay. All right. Thank you. Yeah. Everest again asks, ultimate goal should be to have a DVB-S2 DMOD on FPGA, but needs some skills in FPGA.
There is a Brazilian who was on the Q100 net 3 weeks ago who proposed doing this and has the skills. One of the issues that we came up against there was he would need to buy a number of very expensive licenses in order to distribute the firmware. So yes, possible. He reckons it's about 80,000 elements in an FPGA to do it, so it's not easy. But at the moment, that looks to be one of the less likely, although a very possible solution.
Yeah, sorry, I'm just we're just trying to communicate with who we were hoping to take a feed from lunchtime. So forgive me, I haven't paid full attention to that because we're trying to contact Frank at the moment. Everest has said we could also investigate in DVB-S2 RX FPGA IP. I guess that's what you're talking about, the intellectual property, the IP that would need that, because actually, that's just for this. I'm always aware when we're doing this, we've got a couple of hundred people watching this now, and not all of them are going to be familiar with all these terms if they're, some of the older electronic engineers and wonder what an FPGA is. So is it worth us just talking briefly about that? It's programmable, isn't it? Field programmable gate array is what it means. So can you just tell us briefly what that is so that everybody at home understands?
Okay. It's a step forward from having an IC that you program before you make it and you put all the gates together. So you basically put a piece of data into an IC, and that tells it what gates to connect to what. So it tells it to connect an AND gate to this, the output of this OR gate, and then connect it to this pin, and to feed a clock into another pin. So it's essentially a microcontroller controlled piece of logic. And when I was referring to 80,000 elements, we're talking about 80,000 gates and clock elements put together to decode DVB-S2.
That would take a lot of 7.4 series or 4000 series logic from my early days in Pi.
Yeah,
anyway.
Exactly. And there's a step on from that, which is the ASIC, the application-specific integrated circuit. And this is where, once they've done the FPGA work and they've said, oh, we've got a design now that works, they actually then put that into silicon that doesn't need programming. And that is what's used in our current tuners, is an application-specific integrated circuit that does all this clever decoding that needs a Pentium i9 to do if you try and do it in software.
Yeah, it's amazing. It's hard to sometimes quantify, isn't it, how much processing power you need to do some of these things. I think we kind of take these things that we have in our pockets sort of fairly lightly until we pay for them maybe, and then realise all the technology involved. And we're trying to recreate this as a club. Dave, yeah. I think that's good. We've covered the sort of. I guess just looking ahead, if the club does go ahead and make something of its own, which has got a lot of advantages because we kind of be more in control of it. Maybe that could be done on a pre-order system, something like that, where people have to pay at least a deposit because the club is clearly going to, outlay quite a lot of money to have that done. It's just looking ahead a bit when we've got a solution.
That's not so much of an issue. We think the demand is there, and we the club is in a lucky situation in that it has the capital to be able to make most of the outlay, we think, at an affordable price. Clearly, if the price goes up a lot, we would have to think twice. But at the moment, we think the interest is there. It's just a matter of coming up with a credible solution that doesn't place the club in too much financial risk.
Sure, of course. Well, thank you for the work on this. So that consultation document you can find on the BATC forum, and I guess if there's anybody out there with the talents to maybe help, especially in this, then you'd love to hear from them.
We would, and I would ask people to contribute on the forum thread. There is a lot of discussion there already. So put it out there, and by sharing the knowledge, I'm sure we can get to a solution.
Great. Thank you, Dave. Thanks for this and all the work that you do for the club. And thanks for this update. Thanks very much.
Okay.
Well, now it's time to break for some lunch, which I'm sure we can all do with until 1:15. And this year, something a little bit different for you, we hope. This weekend is the annual International Jamboree on the Air, or JOTA weekend, for Scouts, where radio amateurs help Scouts get in contact with other Scouts all over the world. Well, following a chance meeting at the RSGB and AMSAT conventions last weekend, we discovered that some BATC members were going to set up a TV studio with special event station GB2GP at the UK Scout headquarters. So it seemed too good an opportunity to miss to share this setup with you before all the Scouts descend on the station. So why not grab yourself a sandwich and a coffee now, and we'll be back in a few minutes, hopefully with a live link to Gilwell Park. We'll see you soon. Welcome back. Hope you managed to grab a coffee and a sandwich, and we're going to try and keep you entertained here with a very impromptu, very unrehearsed visit to Gilwell Park. I've never been there, maybe some of you have, but it's the Scout headquarters in the UK, and we've got a couple of the BATC friends there. We've got Frank, in fact, I hope, M0AU, we're going to show him shortly. We've got Lawrence, M0LCM as well on the camera. So hello everybody.
Thank you very much, David, and good afternoon to the BATC CAT23 conference. Welcome to Gilwell Park. Gilwell Park is the headquarters for the Scout Association in the UK, and we have approximately 110 acres of fields and woodlands for camping, for training of the leaders, and also it's the headquarters for our staff here for the Scout Association. So we're currently stood outside the White House. This is, I think it's a grade 3 listed building. Dates back a very long time. We've got a lot of history here, but it's also been extended over the years. The barn has now been converted to our main reception area for the campsite and the activity centre. And further round, we also have the offices for our staff. We have about 300 staff here at Gilwell Park who are full-time employees of the Scouts Association. Everybody else, leaders, activity advisors and everything, are all volunteers. And we have, I think we've got about 500,000 young members in the UK alone. So a very big youth organisation here in the UK. And Gilwell Park, as I say, is our headquarters. It's also home this weekend to Jamboree on the Air for the UK station here. We have a permanent special event call sign, GB2GP, Golf Papa. And this weekend, we're running Jamboree on the Air and Jamboree on the Internet here for a number of youngsters. They're currently at lunch. We have 2 sessions, one in the morning and one in the afternoon. So we're unlikely to see any youngsters actually in the station at the moment. But I'm going to give you a quick guided tour and just show you some of the facilities that we've got here. Gilwell Park the Scouts now are a multicultural organisation. And Gilwell Park has religious centres for many of the different main religions. So behind me, you see one of the newest. This is Gilwell Park Mosque. And across to my left here, we have the Buddhist Sala. And further over behind me, there's a Jewish synagogue. We have an open-air chapel, and we also have a Catholic chapel as well on the site. So a lot of buildings. There's a lot of history here at Gilwell Park. We've owned the site since 1909, and it's been the Scouts headquarters ever since. This weekend, we're actually in a small building called the CIC. It's the Colloquium International Centre. I can never remember the name, so everybody just refers to it as the CIC. And we're in there in a couple of the seminar rooms. But just outside here, our one and only, well, in fact, we have 2 aerials here. We have a Carolina Windham for HF just hanging in the tree, just about to see the lines. And just underneath that, there's also a slim gym for 2 meters. However, that's only half the story. On the other side of the campsite, where we're normally located in one of the classrooms, are our main set of HF and VHF aerials, including a 16-element HF beam on a 100-foot mast. We also have a 2-element on 40 meters. We have a 3-element at 150 feet on HF. We've got VHF, we've got UHF, and we have a full set of satellite aerials as well. Unfortunately, today we haven't got time to take you over to the other side, but we'll certainly try and get some video and post it to the CAT23 at some point, so you can see some of the aerials that we have here. So, without further ado, let's wander into the building and we'll show you around the station.
So just a reminder to everybody at home now, this is live from Gilwell Park, Scouts headquarters, because this is Jamboree on the Air weekend, JOTA, which is an annual event where Scouts work, other Scouts, with the help of radio amateurs from all around the world. And we've got Lawrence M0LCM on camera, and this is Frank.
So the CIC has been recently refurbished. It's been part of the conference centre here at Gilwell for many years. It's formed part of the training, and now it features as the main dining for campers on site. We have a number of indoor buildings for accommodation. We can accommodate, I think, approximately 200 youngsters indoors on the site from the different buildings, as well as all of the camping. In the past, we've had over 10,000 scouts camping at Gilwell Park. It's big enough to accommodate that sort of number. Nowadays, we see much lower numbers than that. But if they are here for a long time, then they can book their food here, and they'd actually come into the CRC and be fed here. So I'm just going to walk you through to the entrance of that. We won't take you into the dining room. You don't want to see that bit, but this is our nicely refurbished building. And it makes for a very pleasant area for the youngsters to come and enjoy their breakfast or lunch or dinner. Okay, so these are the seminar rooms. There are actually 6 in total. They can be opened out into just 2 big seminar rooms. The left-hand set, at the moment, we're only using a very small part of that for our Skype. The event this weekend is Jamboree on the Air and Jamboree on the Internet. Scouts connect with other scouts all around the world. We're using shortwave radio. We have 3 HF stations running, as well as other associated technology, which we'll see in a moment. But we also do Jamboree on the Internet, and we use Skype, especially here, to connect other scout groups. And they'll come on and they'll obviously see the other group and they'll interact with a Skype call. And very often we'll get scouts there singing a song from the local, or they'll explain what the traditions are of scouting in their countries. And the youngsters get a great deal of satisfaction and enjoyment out of meeting scouts around the world using the internet. So at the moment, as I said, this is lunchtime. This is our Skype room. It's all set up. We've got a session starting at 2 o'clock when my next load of young people will be in with their leaders. And they'll be joining us in here for Skype, and they'll see who they can get. We saw Tunisia earlier. Where else have we seen? I think there was certainly several groups around the UK, but yeah, hopefully there's usually a lot of people on from Europe especially. So we look forward to them meeting scouts from there. All through here, we've got all of these slogans that have been pasted on the walls, and yeah, they keep the scouts entertained while they're doing their sessions and queuing for lunch.
And the adults.
Okay, the shack is fairly noisy at the moment. I can hear that now, but we'll try and give you a quick guided tour. Okay, come on in. So this is the main Jamboree on the Air station, and I can see David on the screen at the moment. So it's obviously running on the stream. It's a little bit behind schedule because hopefully it's me up there at the moment and not those two. Anyway, this is our studio. At the moment, I have a television studio set up with a green screen. And what the scouts are doing, or the youngsters, it's not just scouts, it's cubs, beavers, scouts and explorers. I have it set up at the moment so they can come and present the weather. We have a green screen and we have an auto cue on the front of the camera. So they'll come in on the activity and they'll write their script to edit on the auto cue, and then present it on the auto cue, and they can see themselves. So if I stand in front of the camera, let's see if my green screen is still working. Okay, so there's the green screen, and there is the auto cue. And so on the auto cue, I've also got a foot switch here, and I can basically then control the auto cue on the front of the camera and can just scroll it at my own pace. So the scouts come in and they get a chance to write their script, and they then present it to the screen, and we have record. So let's go behind the lights and behind the camera. Let's have a look at the technology section here. Everybody scrambles out of the way. So here's mission control, complete with coffee cups. Thanks, guys. Complete with coffee cups. Here you see the auto cue computer, currently in presenter mode, but they'll come in and they'll edit on that first. We're then running a fairly standard ATEM setup. So ATEM is controlling the green screen. I've currently got graphics and the camera. We've got a remote camera in the rest of the room. If I just switch that back to the data station, there's the data station, and then I can scan that around the HF station 1, HF station 2, And through in the other room, we're doing a bit of kit building. Again, the guys there have gone for lunch at the moment. They'll be back when the youngsters come in at about 2 o'clock. So that's our remote, just running on a little stream deck there that gives me the access to all of the different bits. The remote camera is further over. We'll see that in a minute. So that's that. We've got graphics into the system, so it allows me to change the background. At the moment, I'm running on one of the media clips that's in the ATEM, but we can actually switch to showing video or stills from there. And that is then control. We've got a hyperdeck in here, so I can actually record it. It's nice to be able to record the performances of the weather, the presenting of the weather by the youngsters, and I can just hit the record button on our hyperdeck and just record it straight to disk, which is really useful. And that's the rest of my desk there. Okay, so this is the rest of the station. One of the things that we have got, one of our leaders here, Tom M0LTE, has very kindly designed and written our dashboard for us with a map. And this interfaces with all of our logs and all of our all of our rigs here at the moment. And it shows live exactly what we're doing on any frequency. So when scouts connect to our website at jota.gb2gp.org.uk, they can then see the map and the frequencies live. They can see who we're contacting at the moment. They can also see what we've worked. This has only been running for a couple of hours this morning since we came in. So by the end of the weekend, this hopefully will be full of little dots. And at the end of the weekend, we've got a really good picture of where we've contacted live on there. But it's important for the other scout groups around the world. They can very quickly find out what frequency we're on, so we don't have to rely on the clusters or anything like that to spot us. Okay, let's move forward to give you a quick guided tour of the radio station. We are running data. We're running on a Flex 3000, fairly standard FT8. FT8 is quite a nice mode with the scouts because it allows us to demonstrate very quickly where we're being heard. We run PSK Reporter if it's up and running in the background. No, somebody's moved that off. Thank you. But we have PSK Reporter reporting live our spots, so we can see how far we're getting, and we can see what other stations are on. And obviously, we're able to demonstrate the principles behind the data contact. However, we also have 2 meters and 77s with an ICOM rig. I think it's a 9700, but I'm not sure. I'm getting nods, so that's a 9700. There's my remote camera. That was the one you saw me playing with earlier. Outside, we are running QO100 on narrowband at the moment. We were hoping to have wideband. Unfortunately, Phil is ill and unable to join us this weekend, so we haven't been able to push our television pictures up to the QO100, which we'd hoped for. But we are on narrowband, and Tom here is actually working on the narrowband at the moment. Lawrence has just given you a quick view of the dish outside. We have a unique elevation set up there in order to ensure that it's at the right location, but it works perfectly, and so don't knock something that works. You're on a campsite, what can you do better than a couple of logs? Okay, so our two main HF stations here. Both of these are running into flex radios, and they're running across the network to the other side of the campsite. As I said earlier, our main aerials and our main radio station are located in a cupboard in a classroom on the other side of the campsite. It's about 500 yards from here, maybe a little bit less than that. But we basically then run laptops across the network to the flex radios in the cupboard, and it allows us to operate from anywhere on the campsite. We've got very good network throughout the campsite.
Some name on the next photo. My name is Mark, Mike Alpha Radio Charlie. A little bit closer to the microphone so I can hear someone tuning on the phone.
So that's our, just looking, that's our 40 meter station, and Dave here is working on the 20 meters.
Before I started playing bass guitar, and I joined the band after that. So,
Dave enjoying his time on 20 meters at the moment, I think. So that's our main station. and the youngsters will come in here. We have headphone splitters on all of the radios, so they'll all come in and pick up a pair of headphones and listen to what's being said, and then they'll get a chance to connect with the other people at the other end. Now, hopefully it'll be a lot of scout stations this afternoon, but you can never really tell with JOTA. A lot of people want to talk to Gilwell Park anyway, and so it's always very busy. You can usually be relatively sure of a pile up from early in the morning to late in the afternoon. So at 2 o'clock, this place will be buzzing with youngsters, and we'll have 3 or 4 on each of the radios. Some will be doing the TV station, coming presenting the weather, and then some will be taking part in the kit building. So walk this way. So we have been doing kit building here at Gilwell Park for probably in excess of 10 years now for Jamboree on the Air. We have anything up to about a dozen stations. I've got about 8 leaders helping me this weekend run the kit building. And what we're doing is we are producing, if they haven't stuck that down, here we go. They get to produce a little electronic kit. This one's an amplifier, and then they can plug it into their phone or whatever music device they're using, and they can actually amplify it through a speaker. He says, looking for one of the kits. They've put all the kits away, as you can see at the back. We've got a lot of the kits all ready to go for this afternoon. We're all set up for a big session this afternoon with them. But they can come in. It takes them, we found about 20 minutes to build the circuits, which is fine. They have 3.5 hours with us in total. So between the Skype and the television and the HF station and the kit building itself, they get 3.5 hours with us. So they hopefully will enjoy it and have a good time here and learn something at the same time. We get a lot of questions about how things work, why we do things in a particular way, as you can imagine. And we're always happy to accommodate them. Okay, so that really is, in a nutshell, that's Gilwell Park. It's not really possible for us to take you over as far as the aerials, but as I said, I'll try and shoot a little bit of video later, and for anybody that's interested, we'll post the video, and you can see the size of our aerial farm, which is fairly extensive. David, fairly brief tour, but I hope that gives you and everybody at CAT23 an idea of what's going on. And I wish you a very good afternoon. I'll take any questions if we can. We might move outside where it's a little bit quieter. And we'll take any questions if anybody has them, any comments. Other than that, enjoy your lunch and enjoy the rest of CAT23. Right, let's move back into the corridor. It'll be a little bit quieter.
Well, that's excellent. I mean, it's to be honest, I hope you can hear me, Frank and Lawrence. This has been amazing because impromptu and unrehearsed, but it was brilliant piece. I'm sure everybody has enjoyed watching that. We have got a couple of questions for you. One of them was, are the antennas there permanently at Gilwell Park?
Yes, they are. So apart from the one I've hung in the tree outside, the ones that we have here permanent, we have had a radio station at Gilwell Park since the late 50s. It's moved around the site a couple of times. It used to be in the maintenance shed over the other side of the campsite, but we now have a permanent location over near the camp square. We have an Akiva tower, one of the cell towers here, or at least a linking tower. We had a mast up before Akiva wanted to put one up, and so we came to an arrangement, and they just extended us by about 60 or 70 feet, and we still have a couple of our aerials on the very top of that, and we've since developed and put in additional masts. We have 3 permanent masts and a mobile tower. As I said, we have a 16-element opti-beam, 3-element tri-bander, 2 elements on 40. We can do 6, we can do 2, we can do 70 centimeters. I think we've got capabilities for 4 meters somewhere. We cover everything. Dipoles from the top of the mast for 80 and 160. And yeah, that really sort of covers us. So 24/7, the station can be active here. During the summer, we'll find that if we've got a lot of activity camps here at the campsite, then we can come in and provide an activity. We used to run radio orienteering here. We'll go out into a tent in the middle of the field and run it. The network extends right across all of the camping fields. There are posts in the middle of the field, and you'll find a little cat socket in the side of that. You can go and just plug your plug your Cat5 into it and off you go. That's not a problem at all. So very, very well covered with the infrastructure here, and the site is permanent. Sorry.
Lovely. No, it's excellent. I hope we're not losing the connection after that. No, we're just a little bit shaky there on the connection, but hopefully you can hear me. So it's presumably you've been doing this for quite a long time, so you've seen a lot of changes. And I wonder about youngsters now. A lot of us try and get youngsters interested in amateur radio, and the Scout seems a great way to get them involved. Is it something for many of them that they've never seen before, never heard of before, and that it does excite them?
Yes. So I have been doing this a while, and in fact, I'm spent the first night in one of the patrol cabins over the far side of the site, and I realised that it was the location that got me interested in radio in the first place. We're losing it. You're right.
We've got you. It's okay.
Was the location that got me interested in radio in the first place, and that was 42 years ago. So I've been here a while. Are they still interested? Yes, they are. They're seeing technology that nowadays is a little bit unusual, and we have Morse key in there that they can send a bit of Morse code. Radio generally, although all of them have a phone in their pocket, they don't appreciate how radio works or what it does, and they are fascinated by the fact that with just a bit of wire strung in a tree outside, you can hear all of these people around the world and you can make contact with them. You don't need the internet in order to be able to talk to people. So we find that the youngsters have an incredible interest in it and a fascination, and especially something like the kit building. That's something they don't necessarily get the chance to do at school. It's probably something their parents don't do, and to come and build an electronic circuit that then works, it blows their minds in some cases.
Fantastic. Well, I think we're going to leave you there because we're holding on to the phone signal. It's been great, and we've got lots of wonderful comments, seriously, on both BATC and on YouTube. Dave M5TXJ says, excellent stuff, Frank. They were aerials in my RAE. I'll continue to use aerials. So that's from him. And M0YDH says, hello to Frank from us at GB2WSD watching on QO100. I don't know where that is, actually.
Okay,
do you know where that is?
Hopefully we'll speak to some of the other stations around. I know there are a couple of stations around. Unfortunately, plans for getting our signal from here up to QO100 haven't materialised for the television. Maybe next year we'll have another go. But it's certainly been a pleasure to be able to show you around the station here today, and enjoy the rest of your day. Thank you.
Thank you very much. Yes, I think with some of the pictures from our BATC are being streamed by other amateurs to others making contact through QO100. So you're making it there. Just to one last final question. You're obviously on the air now. You're on the air today until what time, and then tomorrow? Can you give us the times, please, Frank?
So today we've got youngsters here until 5:30 today. Tomorrow we have a session from 9 till 5 with a break for lunch in the middle, an hour at, I think it's 12:30 tomorrow. But this evening, a lot of the operators will be back in the shack. So we should be on from, I would imagine, anything from about 8 o'clock onwards. As to what time we finish, that's up to the operators. I have been known to go right through, but those were in my younger days. Now I think we should probably be here till midnight at least, possibly 1 or 2 for those that are key. But if you do see us, as I said, look out for the website. Give us a shout on Facebook, or I'm not really doing any of the other social media platforms at the moment, but GB2GP has a Facebook page. Please do have a look at it and join us. Give us a shout on there. If you're on the air, please do give us a call, because we welcome any calls we can get. Thank you very much.
Absolutely, thank you. Well, I know I promised it was a final question, but I have got one very final question now, because we have got a few people asking, including Tim G4DBL. Are you looking for volunteers to help at Gilwell Park, or do you have enough radio amateurs to do the things that you want to do?
We're always looking for volunteers, especially the Scout Association looking for leaders, etc. Now, I don't think that was the aim of the question, but I will give a plug at the moment that leaders are always very welcome. In terms of volunteers for the station here, we have quite a big team. There's about 25 of us in total, with everybody that helps on and off. We have 2 other sites this weekend. We have Yulbury in Oxford, and we also have Broadstone Warren down in Sussex. And at those stations, we're looking to establish, or those campsites, I should say, we are looking to establish more permanent radio setup. So if you're closer to Oxford or to West Sussex, it may be something you can do there, but certainly here, very often there's a chance that we might not have people available. So yeah, volunteers are always welcome. We're going through a slight change here at the moment where the room that we use for the radio station is being used for other purposes generally. So we are hoping to change the setup and move to a more permanent purpose-built building at some point. However, that's long-term plans, not short. But yeah, if there is anybody interested, you've got my details as editor of CQTV. Drop me a note. I will certainly get back to you, and I can add you to the list of volunteers that would like to come and operate here. And yeah, you'd be welcome.
Thank you very much, Frank, and thanks to you and to Lawrence for being cameraman for this very impromptu tour, and also to all of your colleagues there, especially helping on the radio side for JOTA and JOTA, Jamboree on the internet as well. And just to prove this really does work and get people interested in our hobby, Andy G4RFX says that he discovered radio through JOTA 40 years ago. So there's living proof that what you're doing is really helpful to keep our hobby alive and bring new people in. Both, once again, thanks very much to you, Frank, and to Lawrence and everybody else there at Gilwell Park.
Thank you, David. Have a good afternoon, everybody. We'll see you at the next CAT. Cheers.
And you. Thank you very much. Thanks very much. There we are. I think that's brilliant, really, for an impromptu tour. It was fantastic, and we didn't expect to have quite as long. I hope you've enjoyed that at home. We're going to let you have a bit of lunch now, and we'll be back here in just under 15 minutes at 1:15 for a talk all about DATV Not So Easy. Michael DL5 OCD will join us live from Germany to tell us all about his software project. We'll see you again at 1:15. Hello and welcome back to the afternoon session of CAT23. Our next presenter is Michael DL5 OCD, who lives near Hanover in Germany. He's been licensed since 1985 and enjoys EME, DATV, HF and UKW DXing, building amplifiers and programming. Today he'll be telling us all about his DATV Not So Easy software program, which he has written to enable DATV transmission using a Pluto SDR. And if you've got any questions or comments for Michael, just pop them onto BATC messaging or YouTube chat, and I'll read as many of them as we can at the end of his presentation. So welcome to CAT23, Michael.
And thanks, David, for the introduction. Yeah, today I want to show you a piece of software starting with the development in the beginning of this year. And now DATV Not So Easy is available in version 1.0. It's available for Windows and Linux. Yeah, I've prepared some slides which I want to show you and also do a live presentation afterwards. Yeah, starting with the slides, DATV Not So Easy. What is it? It's a piece of software. It's a kind of front end for FFmpeg and for encoding and decoding DATV transmissions. It's IP based, platform independent, and open source. Everyone can grab this code and use it for own projects. And it's based on scripts. It's not a compiled version, not an exe file that you know. It's based on batch files and shell scripts for the Linux system. Yeah, some basic features. It's DATV Not So Easy accept input via DShell, video for Linux, also an UDP or an RGB stream. You can also use a file in a loop for a DATV relay, for example. And it supports also the virtual audio cam, the virtual audio device from well-known other software packages. The output is a kind of UDP stream or an RTMP stream. You can choose it in the setup of the software. The codecs which are supported is H.264, 265, and the new one 266. Codec AV1 is prepared, coming soon. And it also have inbuilt support for the brand new firmware from Evereste F5 OEO, which I highly recommend to give it a try. It supports also VBR, has a built-in relay function for DATV relays, and you can also use a built-in RX to have a kind of standalone package. It supports DVB-S2 and GSE for IP communication, which enables you to enable IP communication via satellite or terrestrial. Yeah, it's platform independent. It offers support for the other Pluto, Line SDR, Portdown, Minitune, OpenTuner, and so on and so forth. It's network-based, flexible, scalable. You have three predefined profiles, which you can choose to get a fast start. And also support for hardware and software encoding. You can use hardware encoding when you have an NVIDIA graphics card in your system, and also use software encoding libx265 and so on and so forth. Yeah, concept, schematic. Here you can see that the DATV Not So Easy software steers FFmpeg. It's the FFmpeg do the main job, for encoding and decoding. Since the use the UDP stream to the Pluto, for an example, and on the input side, it accepts input from OBS Studio, vMix, and so on and so forth. Any IP-based application which is able to transmit a UDP or RTB stream. Yeah, and also it has an inbuilt decoder. You may now ask why I need an inbuilt decoder. I have OpenTuner, I have MiniTuner. Yes, of course, but not every software is able to decode every sample rate and every codec right now. So sometimes you have the need to switch between the different devices, and you can start an embedded decoder to grab an UDP stream and show it on your screen. Yeah, when you download the package and unzip it to a folder, you will find this structure, the DATV TX BAT, the setup BAT. You find the config TX ini, which is the main configuration file where all the details about your systems are in, or you have to write the details where you grab the stream from, where you send the stream to IP address of your Pluto, and so on and so forth. I'll show you later. Yeah, this is the configuration file, as I already mentioned. You have the chance to put the IP address of the Pluto, the port of the Pluto, the audio device, the video device, the encoder type. If you want to use software or hardware encoding, the audio codec, and DShow or network UDP when you want to grab a stream which is delivered by an external software. Yeah, you have also a config RxNE, as I already mentioned, with the need of the embedded decoder. You can put the IP addresses in here, and also the ports where the stream is sent to. Yeah, we have the TX portion. When you start DATV, not so easy. It asks you simple basic questions, which sample rate, which frequency, and so on. And you also have the possibility to use the predefined profiles here, profile 1, 2, and profile 3, and also start the last run of your last transmission. Yeah, here you can see when you do not use a predefined profile, these are the questions you have to answer. The codec, frames per second, mono or stereo, QPSK, 8 PSK, 16 APSK, the resolution, the audio bitrate. You can choose the sample rate, the FEC. And when you're all done with this, DATV not so easy starts, and the decoder or the encoder gives you some basic outputs, information about the status of FFmpeg. Yeah, as I already said, you have the possibility to use 3 profiles, and so there's also an embedded profile editor where you can set up your basic profiles, your favorite frequencies you are transmitting on, with your favorite sample rate, and so on and so forth. Yeah, in the new version, when you use the F5 OEO firmware from Evereste, you have the possibility to steer all the basic functions of the Pluto with this piece of software. You can increase, decrease the gain. You can start transmitting, stop transmitting. You have the possibility to change the frequency, and so on and so forth. Yeah, there's also a light version when you do not want the FFmpeg, the embedded FFmpeg decoder or encoder to do the job. You have also the possibility to just steer the Pluto and stream from an external device. Yeah, the control window is almost the same. There you can steer things like frequency, sample rate, FEC, and so on and so forth. Yeah, example, input from OBS via virtual cam. You might know that procedure already when you use DATV Easy from Dominic. This is more or less the same. You start the virtual cam, and then the DATV not so easy grabs the input from the virtual cam. Yeah, a well-known picture of the older firmwares of Evariste, where you have an basic web interface where you can steer all the functions of the Pluto. Keep in mind with the new firmware from Evariste, this front end do not exist anymore. The firmware is completely based on MQTT commands, which I will show you later. Yeah, this is the MQTT Explorer, which have to be used with the newer F5 OEO firmware versions. Here you can see that you have all the informations about the stream, which codec, which FEC, frame type, pilots, sample rate, and so on and so forth. Here you can see all the details. You can also watch the queue, the buffer of the Pluto. That you have to keep an eye on, that you do not flood the buffers of the Pluto, and it won't work properly then. Yeah, the RX portion. As I said, DATV not so easy has the possibility to start an embedded decoder, which is based on the MPV player or FF Play. Here you can choose the number of streams you want to decode. You have 1, 2, 3 streams. You can choose the scaling, and after you input all the informations, the decoding starts. That's example of the embedded decoder, in this case FF Play. Yeah, there's also an MPV interface, an MPV decoder implemented. It's almost the same. You have some different functionality, but the functionality is more or less the same. It grabs an UDP stream and decodes it. Yeah, an example for RX with OpenTuner. Be a nice piece of software which is from ZR6 TG. You could say the encoding with FFmpeg grabs the stream from OBS Studio, transmit it over satellite, and decode it with OpenTuner. So the same thing with Minitune, with the Minitune software. And yeah, some impressions how H266 works. Here I sent out a picture at 25 kilo samples, and yeah, the quality, I think it's not too bad. Same with the MPV decoder, also H266 at 25 kilo samples. Nice and sharp picture, I think. Yeah, roadmap under development, GUI, a graphical user interface, which is the plan for the future. But yeah, some developers already grabbed the code of DATV, not so easy, and started their own projects. Very interesting. An interesting project is an example DATV Simple from Orange, ZS2SCI, I think it's called. And yeah, he already started a very interesting project based on a Node-RED to have a graphical interface for this piece of software. Yeah, you can download this version on my Google Drive. You will always find the actual version there. The link do not change. And yeah, that's it for the presentation. Q&A follows afterwards.
Okay, thank you very much, Michael, for explaining your software and indeed for producing it for the ATV community. So as always, to all of our viewers, if you have any questions or comments, if you've used Michael's software and you've got any feedback for him, this is the time to enter them, please, now, either on BATC messaging or on the on the YouTube chat. We've got a couple of questions for you to kick us off. Can the not so easy DATV be run under the Mac OS,
No.
a kind of Linux? He said. That's Mark M5BOP.
No, it's not for Mac OS. It's designed for Windows and Linux. But I can show you in a live presentation, which I've planned on which platforms it is running and the look and feel.
Okay. From Greg Hopkins, will it run with a Hack RF1?
I've not tested this, but I think with a slight few adjustments, it should be possible, depending on the firmware that is running on the Hack RF1. You have to slightly adjust some parameters, and I do not know if it is possible to steer all the functions of the Hack RF1 from an external device. I've not tested this, to be honest.
Okay, I know in a minute you're going to give us a live demonstration as well, aren't you?
Yeah.
So just get some of these other questions. How about, sorry, this is Mark M5BOP again. How about with DATV Express with NVIDIA or Lime SDR? Are they supportable? And also he adds, looks like Pluto only because it uses the F5 OEO Pluto firmware.
Yeah, you can use this piece of software with every firmware from Evarista. But when you want to steer the Pluto, also steer all the functions and not to jump back and forth between the map interface and DATV not so easy, you have to use the brand new firmware from Evarista, which is completely MQTT based. And I've implemented MQTT into DATV not so easy. So it's more comfortable to use it.
Okay, yeah, thanks, Michael. We're going to hand over to you now, I think, to give us a live demonstration of it if you haven't already seen Michael's software. And as of course, we've still got time for you to ask questions or make comments on BATC messaging or YouTube chat. So back to you, Michael, to have a look at your software.
Yeah. Okay. When you unzip DATV Not So Easy, you will find this structure. There's also documentation embedded in English and German language, where all the basic steps are introduced to get all the things up and running from the download, installation, and the usage. You can find all the informations you need. Yeah. Okay. Starting this software, you see. Oops, I see OBS Studio is not started. Just starting it. I use it as an input device. I start the virtual camera, and then I start DATV Not So Easy. Yeah. You see the screen coming up with the basic question: do you want to use profile 1, 2, 3, use previous parameters, or start with new parameters, or use the RPGSE mode, which is implemented? Yeah, I do not want to go to the questions, so I use profile 3. So DATV Not So Easy starts. Control window is coming up. Here you can see. Here you can watch the output of FMPEG, and also an MQTT Explorer will be started. You can click on Connect. This is my Bluetooth and my call sign TXDVBS2. And here you can see, sample rate 500, QPSK FEC 54, which was given from the profile 3. And DATV Not So Easy is coming up with this control window where you have the possibility to steer all the functions, PTT, change frequency, gain, and so on and so forth. Yeah, let's have a look at the transponder. If a frequency is 3, I choose frequency 1, channel 1, at the left, right next to the beacon. It is 3 right now, and now I start transmitting. I press 1 to enable PTT, and here you can see the signal is coming up. You can click on it, and hopefully it starts to decode. Yes, it's doing so. That's the input, which is grabbed from OBS Studio. The same can be done on Linux. Let's close this. Linux system. I have VMware player to emulate Linux environment, and the look and feel is almost the same. You start your OBS Studio. When you unzip the folder, you also find an install script, which I've implemented in the software, which do install all the dependencies that are needed to get things up and running under your Linux system. You also have the config txni, config rxni. It looks a little bit different on Linux. because the audio device, video devices are quite different. You have now D-Show, you have Video for Linux supported on this kind of platform. But the following parameters are more or less the same. And also you have some help in the configuration file, which helps you to choose the right parameters to get things up and running. Yeah, when you start DATV, not so easy on a Linux platform. Run as program. Yeah, it comes up with the same basic questions as before. You also have the possibility to use the last run or profile 1, 2, 3, or start with a new one. I want to use my last run, sample rate 250. So I choose 4. And here you can see also the MQTT Explorer starts, which I've presented on the Windows system, so nothing new here on Linux. And you have also the control window. Yeah, let's start the virtual camera. It's already started. Let's check if we have a clear frequency. Yep, choose frequency, the frequency right next to the beacon, and I'll start PTT. Good. Here you can see a signal right next to the beacon coming up. Click on it with OpenTuner, and hopefully start decoding. That's
I just want to highlight, if you don't mind, Michael, for people at home, I think the top right-hand window there is kind of what you're looking at back from us. So for people at home, don't look at that, because that's going to be 20 or I think 19 seconds behind us. So I just don't want to confuse anybody at home. So yeah, we're mainly concerned with the middle window there on the right-hand side and the lower one, aren't we?
The middle window.
The one with the video playing now, which is the receiving, isn't it?
Yeah, that's live from Q100, yes.
Yes, thank you, yeah.
2 channels, channel 1 and channel 2. I have 2 mini tuners and have the possibility to decode 2 signals.
Yeah.
Yeah. The lower window here, or the window in the middle, is the window which decodes the stream which I send out from my Linux system.
This might be a reasonable time to ask you some of the questions. One in particular, well, a couple. Phil M0PIT says, using Not So Easy, you can stream RTMP from OBS, then you don't need virtual cameras or virtual audio cables, he says.
Yes, that's a fact.
Yeah. I don't know. I mean, again, I'm always thinking that with a couple of hundred people watching, not everybody is going to be familiar with OBS. So OBS is free software. It is multi-platform, and it's very good. In our experience anyway, you can use it to stream out to the internet. You can use it to record, and you can add captions. You can select from different sources and everything without having to buy necessarily a hardware mixer and that sort of thing. So it's worth, if you like experimenting with amateur television, it's worth exploring OBS, I think.
Yes.
Yeah.
Or vMix. Or
vMix, also, yes.
Also a very nice piece of software, which is also supported by DATV. Not so easy.
Yes, good. Thank you. One Dave GKQ has anyone tried your software on a Raspberry Pi 400? Just wondered how well the H.264 would work.
Yeah, 264 might work when you use Raspberry Pi 4 or maybe the upcoming Pi 5, which have much more power. It might be possible. I've not tested it, but when you use low sample rates and low resolutions, I think that should be possible.
And that's under the Linux version, I guess.
Yeah. Exactly.
Thank you. So if you've got any questions or comments to make, because we're coming towards the questions part of Michael's presentation. This is obviously a live demonstration of his software, but do ask it now, or if you've used his software indeed, let us know on BATC messaging or YouTube chat.
Mm-hmm. Any other questions?
Not at the moment. Mike G0MJW said this must have taken many months to develop your software.
Yeah, around about half a year.
Wow.
I started at the beginning of 23, beginning of this year, and now the development is more or less complete with version 1. I plan some minor adjustments here and there, but not a big deal. The development is almost done.
Yeah, it's excellent piece of work. And you said, I think, in your talk that you were now working on a GUI version of it.
Yeah. A GUI version is under development. It's not only me who is working on that. It's a kind of team. And since this software is open source, it makes it easy for other people to start own projects based on parts of the code, maybe. So there's something in the pipe, and yeah, coming soon.
Okay, well, be careful, because we're all keen to have a go at it, and the GUI, I guess, would make it easier to use. I've got some more comments and questions now coming in thick and fast. Andy G4RFX says, have you noticed any difference in operation across different Linux distributions? So have you tried it on different versions of Linux?
Yeah, I've tested it on Ubuntu, on Debian, on a Raspberry Pi, Raspberry Pi 4.
And everything works well?
Yeah, not on my Pi. Yes, with low sample rates, it works. But I recommend to use Ubuntu, the newest version of Ubuntu, to get this running here on Linux.
Okay,
it's
so Ubuntu is recommended.
Common version of Linux, which is distributed.
Obviously, the software is doing all of the work really here. Dave M5TXJ says, what is the PC requirements to encode H.266?
Each modern PC with a modern CPU. I think I have an i9 12th gen, and this works very good. But also when you try lower sample rates, for example, 250 kilo samples, FEC 1/2, and so on and so forth, it works with low performing CPUs. But you can try that and have the output of FFmpeg in I, which tells you if the system is at the edge or not.
Okay, thanks. Colin G4KLB says, is there a link to Everray software in the instructions?
Yeah. It is.
Okay. Michael EA7KIR, I must admit I thought this as well, Michael. He asks you, why did you call it Not So Easy?
Yeah, there is a well-known software from Dominic, DATV Easy, and at the beginning of my development, I found DATV is not so easy. There are many parameters which you have to adjust and to get a good picture over the satellite, and that's why I chose this name. It's a kind of joke.
Okay. Yeah, well, actually, Keith GU6EFB, he says, is there going to be a graphically interfaced, and that's what I mentioned a moment ago, the GUI interface, which is kind of like a Windows type environment, I guess, more of a graphics base rather than text. You are working on that, aren't you?
That question I didn't understood. Sorry?
Well, he was really just asking, I think, is there going to be a graphics version of it, a graphics interface version, which I think you mentioned earlier in your talk that you were working on a GUI version now.
Okay.
We ought to explain again for people who don't know these everyday terms for some of us, which is totally reasonable. GUI stands for Graphical User Interface, I believe, yeah. GUI. So the likes of Windows and Macintosh, that sort of thing. So you are working on something like that, aren't you?
Yeah, me and other people too. Working some implementations are based on Node-RED, and also starting with the development with C++, but it's a work in progress.
Okay, thank you. Mike G0MJW says, Michael, thanks very much. I assume Windows 7 does not work? ? It says Windows 10 and 11 on the BATC. I understand a modern CPU and also C. So does it work with Windows 7? Do you know?
Yeah, it should work.
Okay.
Not tested it on Windows 7, but since everything is based on scripts, this should work on Windows 7 too.
And Chris W on YouTube has asked, maybe on the Raspberry Pi 5 when it appears. I think you mentioned that you'd made it work on the Raspberry Pi 4.
Yeah.
So do you anticipate any problems running on a 5?
I hope not. I think the performance of a Pi 5 is maybe 25-50% better, especially the graphic card. In brackets, which is used on a Pi 5, the graphic interface is much more powerful, so I do not see any problem.
What made you start work on this? Because 6 months or so, I think you said it took, is a long time to commit your life to doing something like this. And I know that lots of people in the amateur community do, but what particularly drove you to write this software?
Yeah, I'm quite new to DATV. I started with DATV 2022 in the winter of 2022, and I saw some old men experimented on the satellite with H.266, and that was the initial impulse for me to start our own development. With a few code lines at the beginning, and meanwhile, I think 2,000, 3,000 lines of code during half a year of development. And
that's a lot of work.
That's a lot of work. Yeah. Also, I was also very interested in the technology behind DATV to understand how things are working. What is FFmpeg? What is DVB-S2? What are the differences, and so on and so forth. I'm a technician, so I'm very naturally very interested,
curious
into details,
yes.
And it was also one reason why I started with DATV. Not so easy development.
And may I ask what you do as a profession? Do you do software programming professionally?
No. I do not do that professionally. I wrote some pieces of software for my company, but that is 25 years ago. It's a long time ago.
Okay, well, it's really good, as you can tell by the feedback we're getting now. We've got a question here. Can it address both of the receive or RX and TX ports on the Pluto Plus?
For the Pluto Plus, I think Evariste is underway to implement or to adapt his firmware to a Pluto Plus. I'm not sure about the status, but I think on a Pluto Plus it should be possible in the near future. But maybe ask Evariste.
So okay, I hope that answers it, Andy, who asked that question. So it's really down to Evariste to update that part of the software, really. And Greg Hopkins says, thinking about cost issues as a new experimenter in this field, he likes the idea of a simplified SDR Angel.
No.
I don't think it's a question, it's more of a statement that he just likes the idea of, obviously, a software. Maybe easier to experiment with.
Yes, of course. You can use, of course, SDR Angel for encoding and decoding purposes. But I think also the future is to decode in the type of SDR. Since the tuners are not available anymore, and I think we have to find a kind of replacement in the future for that.
Yes, I don't know if you saw the presentation just before lunch from Dave, talking about the various options, and if you did miss it at home, you'll be able to watch this back on YouTube. But the club would appreciate anybody, particularly who has some of the skills, to maybe help us produce a new version of that tuner. Michael, I think we've exhausted all the questions and things that we've been asked. Oh no, one other. Do you know if it would work with the ANT SDR E200, which claims to be compatible with the Pluto?
Not yet.
Not yet. Yet. So that means maybe one day.
Maybe one day, yes.
Michael, thank you ever so much for all of the work you've done on this project and the software and giving it away to the amateur community. I'm sure many of us have appreciated it, and for those who haven't tried it yet, I think you'll be seeing a lot more downloads in the next few days. Thanks very much indeed for joining us today on CAT23.
What's a pleasure. 7-3.
7-3. Thank you, Michael. Well, shortly our final presentation for today, and that's on new narrow bandwidth television ideas with Grant VE3 XTV coming to you from Canada. We'll see you in a few minutes. Welcome back to CAT23. Our final speaker of the day is Grant VE3XTV, who now lives near Toronto in Canada, but was originally from New Zealand as ZL1WTT. There, his local ATV repeater was ZL1BQ, which gave him the opportunity of making his own equipment for bands from 70 centimetres to 3 centimetres. He moved to Canada in 2016 and has built lots of DATV equipment for television. For 23, 13 and 3 centimetre bands, but now comes full circle as he experiments with narrow bandwidth television. But instead of using the original mechanical scanning with Nipkoff discs, he wants to see what could be achieved with just a few kilohertz bandwidth using modern circuitry and processing. We're in for a fascinating talk to end our convention, and don't forget you can ask Grant questions or make comments at any time using BATC messaging or YouTube chat. So a welcome to Grant in Canada. Hello, Grant.
Hello. Good morning or good evening your way.
It's sort of neither really. It's afternoon. But,
afternoon. Good afternoon.
It's quite early morning for you, I believe. Thank you very much for joining us. Yes.
Okay, well, I should get straight into it. That's a very good introduction. Yeah, I've always been involved with ATV, getting involved back in the early 1990s. I saw the ZL1BQ ATV repeater. And I saw the guys doing their thing on it, and that looked quite exciting. And being a bit of a hobbyist in electronic circuit design was my thing, I decided to get involved. And subsequently, as time's moved on, I've built more and more different circuits for video, typically in the domain of analog, and I still believe analog has a big part to play. And this sort of leads into the idea, is it possible to look at ways of using analog and digital in a hybrid arrangement where it's neither one or the other, or a combination of both. And this sort of thinking came about with experiments that were done back in the early 2000s with Murray Greenman and Ken Hasselhoff with his work in Narrowband TV on 80 meters. And a lot of stuff I learnt from those two gentlemen that has been very, very helpful. And Con, I must admit, ZL2AFP has also been very helpful on this current project, giving me pointers how the best way to approach doing such a thing. Well, we first got to start with the man himself, Mr. John Logie Baird. He started doing a lot of this work way back in the 1920s, a man well ahead of his time and what he could achieve within a few kilohertz with an AM broadcast transmitters. The resolution was not that good, but the key part of his system was you had movement, and your brain is quite clever to fill in the missing gaps with the movement. So if you have a rapid change of frames and low resolution, your brain tends to look at that image and tends to rebuild what is missing. So I'm working on the same concept where you look at what you can send and what your brain can interpolate and build upon within the image. And of course, with digital, there are a lot of compression techniques that are used. Some of those compression techniques can be used in the analog domain, some cannot, which I'll get onto later on. And this is also a good point to let everyone know that the centenary of narrowband TV or television in general is coming up shortly, probably in another 2 or 3 years. So be an interesting time for ATV and how we're going to look at the work that was done 100 years ago and the work we're doing today, both in the analog domain and the digital domain. So you can see the man himself. I believe he was a Scotsman and coming up some very clever techniques with his scanning disc. Well, we'll start right at the very beginning, back in 2000, with work with 80 meters and transmitting television pictures via the 80 meter band. And this is what Con, ZL2AFP, had come up with his GUI. And it's very similar to what I've done in Linux. His one was written under PowerBasic, I believe at the time, for Windows XP. It did the job well. It's the same principle. It just simply scans the pixels on the desktop. So you open up a viewer, maybe VLC, or you open up a viewer within the application itself. Then you capture the information and you just do, in the case of Con's Narrowband TV, for his high resolution mode, it took about 3 seconds or more to send a single frame. So you would see on the left is what was encoded. On the right, you'll see what's coming back at the other end. And you'll see in the image, you see the Luma component, and then the black bar at the on the right is your chrominance information. And you have that fine tune, which you get those pilot carriers. There's a pilot carrier within the multiple carriers, similar to what DRM uses, where you lock onto that pilot carrier to lock in the frequency and for all the other carriers with demodulation. Very similar approach that I'm using with the work I'm doing on the new Narrowband TV mode. So what happens, what you see in the box there is basically what you'd see a slow scan. Whatever the beauty about going to an analog system is no matter what, you'll get a picture. And it comes down to how much noise can you tolerate before it's no longer a watchable picture. And of course, Con used some very interesting techniques, which I'm also using, where he does frame averaging, and he does some very other clever things with pixel averaging, which I also do, to minimize the noise, and you can adjust that ratio to get a reasonable picture. So you can see what was capable on 80 meters. This was all done within an SSB channel. And I think the work that Con did was amazing for the bandwidth used. But even at that time, I was very disappointed that we couldn't get moving pictures. And there was basically limitations in the equipment we're using at the time that pretty well restricted us to an SSB channel. I did some experiments also later on going up to 20 kilohertz with some other modes on 80 meters, and it made a huge difference to the amount of information that could be sent. But of course, you got other issues with the path. But the key part of his system was that you would transmit a sequence of images, and you would store them as separate frames, like JPEG frames or bitmaps, typically bitmaps, at the other end. Then you'll wait, the transmission will go for half an hour. One of my transmissions across 80 meters went for about 45 minutes, transmitting a Looney Tunes cartoon. I think it was Sylvester and Tweety Bird. It was very short, it was about a couple of minutes. I transmitted that solid. My 80 meter transmitter got very hot solidly for 45 minutes. Then shortly after that, I ran the snippet of the sound through SSB. So I transmitted the frames one by one sequentially. It took 45 minutes to get a couple of minutes or so of frames. We saved them all, then we stitched them all together through FFmpeg, synced up the audio, and we got a TV picture through on 80 meters. So a lot of the stuff that came through on 80 meters worked that way, would catch the frames one in sequence. The only difference between what Con was doing and SSTV was this would transmit a long sequence of frames, and each frame you would store and you would rebuild them into a sequence of moving video at a later date. And typically you would stitch them together at, say, 1 frame per second or so, because that just minimized the transmission time that you needed to get through. So it was jerky, but you could see very jerky movement. It wasn't that good, but that was the limits of what could be done back in the 2000s. And I know Con was spending a lot of his time working on the software, trying to work out new compression ideas and ways to do things with his technology. And the next thing we need to go into is the difficulty of actually sending anything via HF and Narrowband TV. It sort of seems to be an issue where phase and amplitude distortion are very common. We were running into this in a big way with, we worked into a big way with this with 80 meters, because 80 meters uses with NVIS, near vertical incidence, where the signal will go vertically up, vertically down. And of course, on that path, you would end up with a lot of phase amplitude distortion. With Con's Narrowband TV, he would run a large number of FM carriers, spaced a few hertz apart, carrying the video information. And the FM provided a very high level of immunity, similar to what you get with standard SSTV with using FM carriers. Now, FM carriers are an extremely good way of sending video over on HF paths. So the multipathing was there, but it was to a lot lesser extent than what it would have been on the amplitude of the wave. And one experiment we did try, where we were trying to send amplitude information and phase information, it was a complete dismal failure. Mainly because we had a lot of amplitude distortion and noise coming in. But once we did everything in the FM, or the frequency/phase domain, the pictures came through relatively immune to noise. And of course, the distortion between what was sent and what's been received going through the ionosphere was always a difficult one to work with. Basically, when we tried to do work with digital, Murray was doing work at the time with Domino EX, and he was running error correction and some various modes he was playing with in the forerunner to what we have with Domino EX. He was playing with some modes before that were digital, running error correction. He was actually running error correction as part of Domino EX. And he found the same thing, is once you started putting error correction in there, you didn't really get a huge advantage. The advantage came from sending stuff very slowly and having the noise immunity and a lot of averaging gave us an advantage. But you can see if you go straight up and straight down, you're going to get a large amount of phase and amplitude distortion, which is going to make it very difficult for a receiver to recover a signal. The experiments are done on 80 meters with DRM, with Murray, meant that we had to go down to something like mode D. This was the full broadcast mode of DRM to get anything through, and the reason it worked, it was locking onto the pilot carriers and trying to rebuild the phase information on the signals. So we had to go to those sort of links to get with the digital, but the analog could withstand a reasonable amount of distortion within the path and still present a watchable picture. So the analog had an extreme advantage over adverse conditions that you get on HF. And if you go lower to the horizon and you're within the maximum usable frequency, say you've got a band opening on 10 meters, and of course the 10 meter band's got plenty of space to do a lot of interesting experiments on, the phase amplitude distortion, because the angle going through the ionosphere is a lower angle, will be a lot less distortion that has to be corrected in the receiver end. And this gives you some background of why it's taken me so long to think up of a way of actually getting moving pictures transmitted over HF. Because you've got to take into account how the ionosphere is going to literally garble that signal coming back with the phase amplitude components. And therefore, you need a mechanism to minimize those phase distortions and basically make the ionosphere look transparent to the signal. So any ionospheric distortions that come through, the demodulator can counteract them. And one of the technologies I am working on to do this is called the Advanced Phase Detector, which I've experimented with AM radio for working out the position of the transmitter with respect to the receiver distance information. And I'm also looking at the feasibility of that design of an integrated signal processor for the Narrowband TV, where you'll have a APC, which is an automatic phase control, as well as an AGC, automatic gain control, all integrated into the signal processor as part of the demodulator, to help correct any phase distortions / amplitude distortions coming through, with the ability to lock onto the phase of each of the carriers to have some sort of phase correction. And I'm also looking at the feasibility of using this technology possibly in radar, for example, where if you're looking at objects coming over the horizon, you're going to have the same issues with all the phase distortion and amplitude distortion and the various scatter effects you're going to have with ionosphere. So I'll be looking at the technology in that realm as well. But I think it could have a part to play to minimize the distortions that the receiver ends up receiving. We'll move down. And I'm not sure how well this is going to come through. But this gives you an idea of what we were receiving on 80 meters. Now, the frame rate we're running here is approximately 1 frame per second, but this is sped up. So we take the information, as I said, we store the individual bitmaps. They're not very high, so they don't take up a lot of space. And then what we do is we use something like FFmpeg, stitch all the frames together. And if the audio was transmitted later as SSB, we would combine them. In this case, there was no audio. Con didn't have any audio. This was live from the camera, from his webcam. And we sped it up. And that's what I would expect the new mode to look like. It's just going to be noisy. But you'll see movement, real-time movement. And there's a lot of averaging going on. So you can control the amount of averaging. It'll drop the resolution, but it'll also minimize the amount of the noise. So you can sort of look at ways to mitigate the signal, the noise coming back through in the signal. So that is a key part.
At this point, sorry, Grant, to interrupt you, but yep. I think we should explain to everybody at home as well. You're doing this under challenging conditions because you only have a DSL connection. because you're going to be in quite a remote part of Canada. And what we don't want to lose is any of the actual video, the content. So you sent us the 2 videos that you're going to show ahead, didn't you? And maybe at the moment, if we can play that out, I think it will be a fair representation of what they are to show people it live from our studio rather than through your DSL, because it might have slowed things down a bit more. Is that okay?
Okay, I'll let you run the video from Con on 80 meters.
That's it. Now, we only saw a little bit of that actually in the transmission from you.
Okay.
So we're now back to you and your live slides, but and the next time we'll play a video as well. We have sympathised with having just a DSL connection as well.
Well, I think it ties in very well to this talk and what the motivation is to get back into ATV, because I'm in the middle of nowhere and we've got to get TV pictures to somewhere where people want to do ATV, to my remote location. So it means I have to think outside the box and come up with new ways of doing ATV. So I think it ties in well. Anyway, you'll see there that what happened is the noise that was received through the 80-meter path just was simply displayed as noise on the video. Now, these were FM carriers. They had a certain amount of phase and noise immunity, but ever so often with selective fading that happens with near vertical incidents, whole chunks or lines will literally disappear in the picture. But if you lose a line, you can still see there's an image there behind it. And with the movement, it just makes it a lot easier to see what's in there. And of course, if you get a whole sequence of frames and you have a frame buffer, which I'm working on with the newer software, you can do some averaging between those frames and just average out some of the noise. So these are the techniques that Con was pioneering back in 2000. Nothing new in them, but the way he was using them was quite clever. Now, on the left there, you see that there is a illustration of the pilot carriers and the information carriers. These are all FM carriers. And there looks like there was 72 of them from just looking at the table. I cannot remember, it's a while ago. But they all fitted within 2.6 kilohertz. And the importance of those pilot carriers, which is also important what I'm doing, is you need a reference, a phase amplitude reference. More of a case here, a phase reference to lock onto, so you make sure you're dead center on the information that's been centered, so you're not off to one side or back again. So once you've got the lock and you're actually locked in onto those carriers, you actually start generating a picture. If there's a mismatch between them, of course, the best way to describe it is what you get with FM television. You get a lot of black sparklies, you get a clipping on one that goes all whitish on the other, and it just makes the noise, just amplifies the effect of the noise. So you want to be centered. So these pilot carriers that are right at the edge of the pass band are fitted in there because they don't carry anything other than a reference to tune into the center frequencies of each of the carriers. So each one, so in Con's case, he's doing something slightly different to what I am. He would actually divide the picture up into 2 parts, the chrominance and the luminance part, and they'll all be transmitted as frequency, as frequency division multiplexing, where they'll all be on different frequencies. So the chrominance and the luminance would be transmitted together. I did have a long discussion with him on this, and he says the reason he did it is simple. It's easier. And he's right. It is easier to send everything at once. But in my case, I needed to think, okay, if I sent everything at once, there's going to be a lot more spectrum requirements. If I can sort of shift things to different times into the time domain, there are some advantages in doing that. And I spoke to Con about it, and he saw the merits of what I was planning to do. But he did highlight it's going to be a lot harder to do because you've got to synchronize. You've got to synchronize the data frame, so you're right at the beginning of the frame, so you know in the time domain which parts are the luma components, which parts are the chrominance parts, which parts are the wavelets, and the other part of the motion frame. So you've got to know where they are in the time domain, and therefore when signals get weak, you have to have the ability to accurately trigger at those right timing intervals to recover that information. Okay, we'll move down. I think that's a good illustration of what was achievable back in the 2000s. Okay, there's another video here. I'm not sure what you want to do there, David.
Yeah, I think we'll play this one out. So in the bottom right there, we're just seeing it, only catching the odd still frame. So I think just to be representative again of what you originally shot, we're going to now play that out.
To really put it together with some detail of things. nice and stable. It has a crystal oscillator for the tone decoding with 3579 MHz standard USA colour frequency. It lets you get really good decoding. You really don't need any setting up for the frequencies. It's the crystal oscillator and everything works out fine. So it's a very good one for that. Ident and call sign from the Mike G0MJW ABS, so that'll be quite good. Victoria, Wellington, holding Ricky's Quaggy, looking at the Belmont DATV repeater on the monitor.
Victoria, holding up.
And Ricky, to the L2 RW.
I think, okay, just looking at the video there, you can see that that video was originally recorded on 8mm. That was then copied to the 8mm tape, I cannot remember, standard 8. Then that was recorded to VHS, and from VHS, as you can see the smeary image, that was digitized to an MPEG, I think initially an MPEG 1, then I took the original VHS and coded it to MPEG 2. And there's a lot of losses in the way, and the reason I decided to start with a VHF reference is I wanted to know, I had several recordings that were done on standard VHS. I wanted to compare the narrowband TV resolution to get some idea, to get something. I think VHS is a good reference point to aim for. It was not very high res, but you could see what was happening, and I wanted to work out what would be the number of carriers I would need, what would be the frame rate to actually get some movement. So I needed a reference. So that video was actually recorded as a loopback test through the Narrowband TV application and then stitched together with FFmpeg with the WAV file, and then that built up that video. So what you saw was compressed. The luminance was compressed. There was the only thing that wasn't compressed. Sorry, the chrominance was compressed. The luminance had very little compression. There was a lot of compression in the wavelets. That's the highest point of compression, and there was a little bit of motion compression in there. But that when I recorded that was before I did a lot more work with the motion side of the frames. So at the moment I'm running with a little bit higher compression. So what I ended up with through these experiments was a picture size approximately 240 by 192. Now, I couldn't transmit that over on HF. When I did the calculations, we're getting up into some horrific bandwidths. So I decided, okay, well, we can't run 25 frames a second. We can't run it at that resolution. So I decided to drop it down to 12.5 frames. And what you saw was recorded at 12.5 frames. It was a bit jerky when there's a lot of movement, but 12.5 frames seems to work. It's not brilliant, but it gives you the impression there is movement there. So the luminance and chrominance compression, I'm still experimenting with different compression ratios for the chrominance, but it's 4:1, and we're running basically odd and even lines in 2 different time slots for the luminance. And I discovered pretty quickly playing around with this technology that the luma part of the signal is very unforgiving. You cannot do any compression realistically with luminance in the analog domain, because as soon as you do any type of compression, I was doing some interpolation between the odd and even lines for the interlacing, and where I had one interlace running a lower resolution than the other, and I found that didn't work, because as soon as you do anything to minimize the amount of information being sent within the luminance channel, it just looks a lot duller, and a lot of the detail quickly disappears. So the luminance channel is very, very unforgiving, and I think a lot of people before me have run into the same problem. Con ran into the same difficulty. But of course, chrominance luminance pull down is definitely a good way of getting compression, and VHS had quite a horrendous pull down ratio for the luma channel versus the chroma channel. So you can get away with a lot of chrominance compression, which is an area where I'm going to have different modes where you can run at different compression ratios. Sure, the color is going to get smearier, get very smeary and horrible looking as you actually reduce the amount of color information or switch it off altogether to go to just straight luminance. The other issue I ran into is I had to go back to a base resolution. And the base resolution of a 120 by 96, 120 pixels across by 96 lines down, and I found I could transmit that within, when I did the calculations and the modeling, I could get that down probably within a few hundred kilohertz, and with some compression you get that down a lot further. So I spoke to Con and I say, look Con, I'm having problems here. I'm having issues trying to get, I tried to explain the issues I'm running into with the chrominance and the luminance compression, and I spoke to him about some experiments he was doing with wavelets. And because I wanted a method of sending the velocity, the rate of change between pixels. Instead of sending all the pixels, I just wanted to send the rate of change between pixels, which was the wavelet component. So we had a bit of a discussion with wavelets. And I'm not sure if the mouse shows up, but here you can see this illustration. On the left is the raw image coming in. I picked this image because it's a colourful image with a woman in a clothing store, lots of bright colours, lots of detail. You got the discs in the background that have a very fine gradient in it for bandwidth, and the very fine dots. And what happens is I take that signal, I break it up into chroma luma, and that ends up in the box in the middle. This is the test application, and it would take the luminance chrominance, build it up. That gives you a resolution of 120 by 196. Then I did another process where I stripped off all the high frequency components from the luma channel only, and they were sent as one bit of information that was sent as wavelets. Now wavelets just is simply on off state, and that allowed me to send the velocity or the rate of change between the pixels, allowing me under very good conditions, if there's not much noise present, the wavelets would actually rebuild the detail lost from the luminance side, and you would actually get back to the original resolution of 240 by 192. And the beauty about using wavelet compression, one bit, is it took up very little bandwidth to get a massive improvement in the high frequency components. So I wrote this little bit of software just to do this and break the signal up into its various components, and that's what you see there. Then, of course, you can only go so far with software and compression. Now, this being a hybrid system, being digital, everything happening in the digital domain, some of the signal being sent as digital, some of it sent as analog, there's absolutely no room for bandwidth for error correction. There's zero error correction everywhere. If there's errors, you've got to encode the video and the audio and all the various parts that get transmitted in such a way that it's fuzzy. So if there's a bit flip or a bit somewhere flipping, it's not going to cause a error. It's just going to change a different, say, luminance. It's going to be a little bit brighter, a little bit darker. It's going to look like fuzzy noise you used to get with analog television. So the idea, whatever's received just passes through the chain. If the signal from the AGC gets to a certain point where the signal is very weak, it just switches off the wavelet, then it starts doing a bit of averaging on the signal. So I had to look at how information is transmitted. Now, digital is extremely lossy when you take into effect that you have to have points in a constellation to transmit digital. And you have to have sufficiently low enough phase distortion and amplitude distortion to work those quadrants out where the information lies and what each one of those dots represents. So the whole idea of going to, say, 16 APSK or QAM or 16 QAM, 256 QAM is great. The more information you put into it, like 256 QAM, the more information you can transmit, but more error correction needs to be transmitted within the presence of noise. So the whole idea is, let's forget about this constellation stuff. We don't need it. Let's just run things purely as straight QAM. So I'm running 65,000 QAM, basically 8 bits squared. It's a word, 16 bits, so 65,000 states. So we can just call it QAM. And so therefore you get a round fuzzy blob. Well, we've got a problem there because we've got to control the amount of amplitude shift and phase shift to work within the confinements of the amplifier. An amplifier has its compression point, 1 dB, 2 dB compression point. So you can't push your QAM constellation into the compression point because it's going to add distortion. So I decided straight away we go to a spherical type of modulation where there are no points. Like if you've got 64 QAM, you get a square block. Those edge corners are basically lost because they run as the compression point of the amplifier. So I go to a circle. So I concentrate everything into a circle. And the noise reduction, what it does, since there's no error correction, it works out the probability of that being signal or that random noise. And there's several techniques I use to work out the difference between noise and the noise and the actual signal using good old noise reduction techniques. And Ray Dobie was a very good pioneer in this area with Dobie noise reduction, which we're all aware of. So a lot of his research was quite useful, and a lot of other research on noise reduction subsequently has been quite useful. So what you end up with is a QAM donut shape, because the noise will always appear right at the lowest point. So you've got two limiting factors, is the compression point of the amplifier and the noise at the receiver. So you want to concentrate the information where you have the least amount of distortion and the least amount of noise. So the modulation technique I'm using is this QAM NR system, where it gets rid of all the issues with the constellations, but the downside is there is no error correction. It's more akin to analog, but it's sending basically digital information that can be decoded. But the idea is encoded in such a way that a small error does not require error correction. It's only going to give a small error at the other end. Now, working through this, we have the graphical user interface. Now, I'm not a programmer, I'm a hardware guy. I like to work with soldering on and physical components. So learning software has been quite a steep learning curve for me, but basic. So I've done a lot with Gambas and Visual Basic. I did some background in that, and I found Gambas was easy to learn from my Visual Basic background. So what I did is I took what Con did. I had a encoder, decoder, and what I do is I have a media player, so I'm just running the media player that's part of the Gambas module. I am capturing the pixels from the display in the resolution of 240 by 192. Then I'm running through the various from that point. So as you can see, there are ability to take a file, read the file, encode it, transmit it. There's ability to go straight from a UDP stream. So you want to stream to the application, you can do it for a UDP stream. So you put the URL in there, you can do it from a webcam. And I'm also doing a lot with the good old PVR 350 because I'm still very much in the world of analog and composite video. And I can just feed a composite video signal straight into the back and get the PVR 350 to digitize that video and just display it, so I can just feed an analog video source into the encoder. Very useful. And of course on the other end you have the decoder. That's what the decoder looks like. Usual controls, contrast, brightness and all the rest of it. Has a few extra features, aspect ratio, because the problem these days we're 4:3 and 16:9, so it runs both. You just select which one you want to use. It has wavelet on off, so you can switch the wavelets off if it just gets too noisy. And it also has scaling, where you can adjust the scaling. So if it's really noisy, you want to scale down the image. Otherwise, it just gets really distracting for the noise. So the idea is to just keep a picture present no matter what. Where digital has a cliff effect, it literally falls over. This will just keep on going, similar to what Con was doing back in the 2000s. And the engine behind this is FFmpeg. You hit record. The record simply captures the sound as a WAV file, captures all the images as bitmaps, and just goes bitmap 1, bitmap 2, bitmap 3. I've set a limit to 4,000 bitmaps, and hard drive space and RAM space are nothing these days, so 4,000 bitmaps is not going to take up a lot of RAM space on the RAM drive, so you just capture all those. Then you hit the record button, then it just runs a script in the background, tells FFmpeg to stitch all those frames together and then to stitch the audio in, and it spits out an MPEG-2 file, which I can then push back out the PVR350 MPEG-2 card as analog video, or I could just display it through HDMI. It's not a big deal. So I needed to have some way of testing the ideas and the concepts I was working with, so this is how I did it. This is the block diagram. I don't know how many people have got the CQTV article, but it's published in there. There's a lot going on inside the software. First of all, you've got to, as I said, take the image, the raw image, break it into its parts, the luminance, the chrominance, the wavelets, and the motion. Then I'm stitching it together in the time domain, very similar to how BMAC used to work in DMAC, the old analog systems. So you have a frame, it's made up of luminance, chrominance, wavelet, motion. Then you have two frames, and when two frames are received at the receiver, it interpolates the missing frame in between from the motion vectors and then gives you a frame to incorporate. So it allows me to, in theory, which I'm still perfecting, the ability to run at 6.25 frames per second, and it will interpolate 12.5 in the receiver, again reducing bandwidth. But again, with bandwidth, it's a law of diminishing returns. It's like a bell curve. You get to a certain point with noise reduction and compression, and the compression used has got to be fully reversible compression in the presence of noise, because there's no error correction. So you end up with a bell curve. And the Shannon bandwidth rule is very real. I sent some very let's say, not very pleasant words have been used with Mr. Shannon. It is real, and the Shannon bandwidth limitations, I'm always cursing because it's there, and you've got to work within it, and the laws of physics are unforgiving no matter who you are. You've got to deal with it. So there's a limit to how much compression you can run within a given bandwidth, to how much resolution and how much video information you can send, and so it all comes back to how well you can process the signal to be immune to noise coming back the other end. The audio I've not spoken much about. It's basically the CQAM, which is what's used for AM stereo. I'm also looking at the CQAM system, and I'm also looking at the CAN system. The CAN system is very clever that it uses sidebands to send information, where the CQAM system uses QAM to send the information. And the idea, of course, is the amplitude carries more information than the phase. So you sum the information for the amplitude domain, you subtract the information for the phase domain, and that's how you send the QAM signals. And that applies for the video carriers and the sound carrier, where you just compress them down that way, and then of course you get you get left minus right, left plus right, and then you'd have line 1 minus line 2, line 1 plus line 2, and you get the idea of the encoding process. So it's a lot going on, and of course there are two noise reduction stages, one in the digital domain and another one in the analog domain, which I'm still working on. And I hate to say it, but with this project, it's been more frustration and failures than anything else. But as I've always said, with failure comes insight, from insight comes discovery. So I've got a good idea what doesn't work now. So it just leaves what probably could work. So we'll move down. A quick overview of the Win PVR 350 card, MPEG-2 based. Oh, this card is amazing. With Linux, because the software and everything runs under Linux, you can talk to this as a file. You can say stream to this location in the kernel, which is dev drive for videos, blah, blah, blah. Stream the file from FFmpeg, and the way you go is so you end up streaming straight out of the card and into a TV monitor, and you can see down here on the Sony monitors the image coming back through the card. And it's very easy in software to enable the PVR 350 to take analog video in, analog video out. And I can use HDMI, or I could use streaming, as I said earlier, for UDP, or playback a file. It's all good. So there's the hardware. They're not very common these days, but you can pick them up on eBay, next to nothing. And I believe you can get a PCIe to PCI interface connector, and you can plug them in, and you just plug them in Linux kernel, sees them right away. And I just find this a very useful analog to digital interface to work with anything I do with DATV/ATV. And the other part I have not gone into yet, because I've been focusing solely on the compression side, the noise reduction side, is the modulator, demodulator, and how I'm going to take the data out from the application into, say, the FPGA, which I'm going to then run the DSP modules to do the filtering and generate the carriers and all that sort of carry on. So I've been experimenting with this particular USB parallel interface module. It looks like it will have sufficient bandwidth to talk to an FPGA, and I can talk to that. The FPGA will talk to the various peripherals that I need, like the A to Ds, D to As, the static RAM, all the important stuff, to send the stuff out and generate the carriers. Again, I'm not a big software guy, so working with DSP, FPGAs and development software is a steep learning curve, but I have modeled some ideas how the transmitter is going to be built, or the modulator. And of course, the most difficult part is the decoder. The decoder's got a lot more going into it with the phase detector and the signal processor. It's the first time I've actually needed to use a signal processor for television. Usually you have a demodulator, then that feeds out the video signal. But no, you've got to have a signal processor to work out the probability of noise versus the probability of signal, and to do some phase amplitude compressions for any ionospheric effects, because this is a ionospheric mode that needs to counteract all those issues that you inevitably will run into. So that's what I'm tinkering with. At the moment, I'm taking a bit of a break from it. I'm just doing software modeling at the moment. I've got a few ideas drafted about the hardware design for the modulator, demodulator. Unfortunately, I just can't get something off the shelf to do it and budget. This has to be optimized to get the best signal-to-noise performance possible, and to encode the signal the best way possible to get the signal to be transmitted with the minimum within the presence of noise. Here is a basic mock-up of the idea of the transmitter. Again, that was published in CQTV. As it says, very much a work in progress. This has changed several times over, but the basic concept's the same. Everything comes into the FPGA. The FPGA generates all the timing signals through the PLLs and so forth. Takes the frames coming in from the software, stores them, alternates the frames, transmits them, encodes them. Then we get to the digital part where it goes from digital to analog, D to A. Then we have another section which is the analog noise reduction section, because once we get to the analog domain we run for another pile of noise reduction, which is basically good old frequency amplitude compression. And then that gets up converted up onto the 10 meter band, and then it can be just standardly amplified for a conventional amplifier. So, but this is the part that's going to be doing all the work, and it's going to take a lot of time. So I've already resigned to this being a multi-year project. It's taken me a year to get some idea on how the software is going to encode the signal and what needs to go into the software encoding to what goes into the FPGA hardware encoding side of it. So I've got that pretty well worked out at this point in time, but at the moment everything's pretty well got sorted on the encoder. Next year I'll be focusing on developing the hardware to maximize the signal to noise for transmission and reception. And that's pretty much a run through, and I'm pretty sure there are questions. So how are we doing for time, David?
We're fine. We have a good 10-15 minutes. As you're the last speaker of the day, actually, it's fairly casual or relaxed, should we say. So if you at home have got lots of questions and comments to ask Grant, you can fire away. So please do that now. We haven't actually got anything yet, I think, specifically about this, but I'm sure everybody's been intrigued with your introduction. And as you mentioned...
Well, we can certainly go over it.
Yeah, absolutely. You did mention this, and this is a good point to mention, because some of the people watching may not be members of the BATC. And as part of your membership with many other things, you do get this wonderful magazine. And as you said, Grant, there's a big article in here, I think 4 pages, possibly 5, this month, all about what you've just described, a new type of hybrid television. So particularly, I think if you don't just want to do the HD, in fact 6 pages looking at this, so lots of information there in the latest CQTV magazine. And there is a lot that you can do, your experiment yourself. You've been honest and said you're not a software engineer, which of course a lot of the people we've spoken to today and heard from today are software engineers. You're essentially hardware, and I guess you've been dragged along and had to learn some of the software for some of these techniques. It was a wonderful project.
I'm an old school broadcast engineer. I came into the world of television in the analog days, very familiar with an analog video signal. I've built multiple VSB transmitters, FM transmitters, filters, group delay correctors, you name it in the hardware domain, I've done it. But I've been dragged kicking and screaming a lot of the people into the software era, and I admit there are a lot of advantages into using software, and I've had to learn to work with software. Luckily, in the days of DOS, we had Quick Basic, and I used to write applications in Quick Basic, and then went on to work with Visual Basic, and of course Gambas is brilliant. It's basic for Linux, it's Visual Basic for Linux, and it's just very easy to work with Gambas because you just pull in the various modules. You want a media player, pull in the media player module. If you want something else in there, you can put in other modules like encryption, compression algorithms. Because I initially thought, okay, I can use a run length encoder and that'll do the compression. You can't run a run length encoder and Hoffman encoding and all this fancy doodah stuff because you need error correction. Guess what? There is no error correction. So a lot of stuff you instinctively think you can work in the digital domain doesn't apply to what I'm doing with this hybrid mode because it doesn't use error correction. And that has been a total paradigm shift in thinking of sending information in the digital domain that's sort of a hybrid between analog and digital that has zero error correction, but only only has a bit of noise reduction to minimize the impact of noise on the valid signal you're trying to receive. And I'm still actively experimenting with ways to interpret in the signal processor and the receiver to differentiate between noise and the valid signal. Because no matter what, how noisy things get, you want a probability to know where that luminance value or that chrominance value lies and to build the picture. So there's a lot of processing involved there. And subsequently in the article, I've been looking at AI. In another 10 years, we could be looking at an AI module. We take the noisy TV picture into the AI module. The AI module has the intelligence to subtract the noise from the video. And I think that's going to be a very interesting development in years to come.
Yeah, and I guess that when you think about the analog world, analog electronics, that's always going to be the most efficient form of communication because you're not changing it in any way, are you? You're just transmitting it. It's only when you can't transmit it because you haven't got enough bandwidth, or maybe you're trying to get it over in a very, very noisy environment, that you need to encode it. So maybe your idea of combining really the two, some analog and some digital, might be quite a nice fresh approach.
Well, no one's done it. Obviously, someone has done it in the past and failed and gave up on it. But I'm a sucker for punishment, so I've decided, I want to do ATV, and I live in the middle of nowhere, 350 kilometres north of Toronto, and what I've got to do is compress the video/audio information down to a point where I can get it over an HF channel, and there's only one band that will allow me to do that, be 29 megahertz, so I'm looking at ways of shoehorning it into that band, and maybe in another couple of years, maybe by the centennial of John Logie Baird, we'll have some pictures on the air and be able to enjoy the hobby once more.
Wonderful, yeah. I mean, would you say that as someone who's come from being essentially a hardware engineer and, as you, in your words, dragged kicking and streaming into the software era and things, would you say that this sort of project is a good way of trying to learn a bit about software if you are mainly a hardware engineer?
Yes, I think it's good because it has a balance of both. Instead of just bodging a bit of hardware, you buy, say, an Arduino and plug in a card, write the software. Sure, it's working at the hardware level, but in this application, I have to optimize the hardware to work for this particular mode, maximize its performance in these adverse conditions, and then apply software to get it all to work. So it's interesting because using all my hardware experiments and resources and what I've done in the past and how hardware goes together and what works and what doesn't work in that domain, then I'm looking at, in DSP, how would this work? Should I do this? So it is very interesting, and I'm finding it a very interesting area because I've never really delved into digital signal processing and your various forms of filters you got there, your averaging filters and various other ways of using wave tables to generate sine waves or triangle waves. And it's very interesting just learning DSP. So I find by taking on these projects are very challenging, but I learn volumes from doing them. Put it that way.
Absolutely. Okay, well, we have one question so far, and I'll read that to you. But if you've got a question or comment, or if you've ever done anything with narrow bandwidth television like this, or also if you could help, and if you're interested in joining Grant on this project, then please put a note into BATC messaging or YouTube chat right now. Now the question we've got is from Dave G8GKQ, and he asks, what FPGA development environment is Grant going to use?
I do everything with Qwertys because I've tried Xilinx. I just don't like Xilinx. I'm a hardware guy. The good thing about Qwertys and the Intel chips is that you can go to the symbiotic level, and if you want an OR gate, you cut and paste, put an OR gate in there. So I like visualizing the logic sequences, the OR gates, the AND gates, and that. And I like that at the top level, and then I'm learning VHDL. VHDL is a bit like BASIC, but a bit different. But with VHDL, I can program a module that's specific. Then I can bring that module and import it into the schematic layer at the top, and that helps me to think, okay, here's the hardware part, here's the software part, and it makes the development from my background in hardware a lot easier to do, because software guys will jump straight into doing VHDL and that's it. And I've had to work with those people, and it does my head in, because I'm a visual person. I've got to see a schematic, how the thing lays together, and how this VHDL module fits into the overall structure. I think that probably gives you a good answer of the way I've approached it.
Yeah, absolutely. Well, I must admit that's the way I tend to think as well. I was never much good at the theoretical things at school, but give me a circuit diagram or an actual PCB to hold, and I get it. So this does seem a great project to get involved with that. We've just put your website, or actually the QSL, because you go on your website, it's ZL1WTT. I've got qsl.net/ZL1WTT, and I think that links you to your old New Zealand website. Is that right?
Yes, I think I put an explanation on there. I just, of course, new call sign, I'd have to go back to QSL and say, hey, this is my new call sign, and I'll have to go through re-updating it all. So on the title page there, as you come into it, does talk a bit about, it's now VE3 X-Ray Tangle Victor. And I must admit, I have been very lazy of late with work commitments and other things. I haven't really done any updates. I think the last updates I did on the website were back when we had lockdown, and I had the time. So I haven't really updated much on that site, probably in the last 2 years, so it's a bit antiquated, but it's there.
That's all right. And you would encourage some people, if they're keen. You worked with Con, you said some years ago, and if there's anybody who's keen to work with you on this, it sounded from when we talked the other night at rehearsal that you would be keen to work with them.
I'm quite happy to I think it's a good idea to get a broad perspective of ideas, because right now at the moment I've hit the wall. I've had failure after failure after failure, and it's good to just take time out from the project, and I probably will get back into it in the spring. But maybe someone will come along with another idea that may push things along again. But I'm just working on other projects unrelated to Narrowband TV. I'm still playing around with the demodulator idea for, as I said, some other applications. And that's where I'm focusing. Sometimes what I do is when I hit a brick wall in a project like this, I go away and do something totally different, maybe for 2 or 3 months, 6 months. Then suddenly I get an epiphany or an idea. Maybe that will work. Then I come back to the older project, and that's how I approach development of ham radio projects in general and commercial projects. To avoid burnout, it's important that you sort of go far as you can. It's got to be enjoyable. Once the enjoyment goes, you just switch projects, go on to something else. Then, okay, what if I did this? Then you find you start thinking about these older projects, and you come back around full circle back on them again. And that's how I approach taking on projects like this. I never go 100% for 2 or 3 years and develop it. It's usually 3 or 4 months here, maybe another 2 or 3 months next year. Then when I discover and my skill set improves a bit more, I'll try something else, and I get another breakthrough. So this is why it takes so long for any of my projects to see the light of day now, because it's just a steep learning curve. And I just need, for my own sanity, to take regular breaks and do other things.
Makes sense. A good, healthy lifestyle to do that as well. A couple of actually comments for you. Dave M5TXJ says, is this another option for 10 meters perhaps? And then Mike G0MJW says, top band would be much more stable. So obviously with such a low bandwidth, you could probably work on those bands. Have you thought of that yet?
We'll start with 10 meters. Well, basically anything above 10 megahertz, it's got sufficient space to run this, but 29 megs is ideal, because when I tune around on 29 megs on the band opening, you have the guys running AM around 29 megs. Then you've got the guys running FM on the FM repeaters up at the top end of the band, and generally there's very little in the middle there, and this would fit quite happily in that little space in the middle. On 10 meters, and I think it's the only realistic band, because this is designed to work with ionospheric propagation, And Con Murray, Z1 BPU, always found it amusing when people would transmit Domino EX on 2 meters for an FM transceiver. And he said, well, that completely negates the whole entire purpose, because you're taking a frequency hopping MFSK signal, then you're frequency modulating it, then you're transmitting it, demodulating it back to FSK, then decoding it again. So you go through 2 steps, and you completely negated the whole purpose of the modulation system. So one thing I did learn from Murray is that the modulation system and the way the modulation works is pretty well dictated by the mechanism of propagation. So yes, it would work on higher frequencies, but the advantages would not be there, because the advantages are there in the amplitude phase compression that you need to do to rebuild the signal from ionospheric distortions. Of course, it would transmit on higher bands, but it would not be optimized for higher bands, because you wouldn't need to go to the same extreme lengths to do those corrections in the receiver or / the signal processor.
Yeah. Okay, we have got a couple more questions just come in, sneaked at the end. Actually, a comment, I think I can understand it. Michael EA7KIR says it's just taken him 2 days to realise that an IR filter, I think that should be, is just a CR filter. So maybe that's someone from a software perspective just coming into the hardware world. Mike G0MJW says we did manage to send DATV over 10 meters using QPSK in 20 kilohertz. But the multipath was the issue. It worked once or twice for a few seconds. That was DVB-S, and it doesn't really cope. He says that another approach might be to use coding like DRM. As always, the challenge is the DSP.
Yes, that's a good approach. Well, I've gone to a different approach. As I said, I'm using like a radar system has. You have a receiver, and that feeds to a signal processor to filter out all the noise and the unwanted information. I'm taking that approach here, where the demodulator and the signal processor are integrated. You have an APC, which is an automatic phase control, and an AGC, which is automatic gain control. It comes back from the phase detector, and then it talks to the FPGA. This is done with PWM. So it's all pretty well done in the analog domain. Then there's a control loop that comes back. Then yes, a DRM approach is a good approach, but again, it's very wasteful on bandwidth, because you have to send a huge amount of error correction for it to work. So the pilot tones and using the pilot tones to rebuild a characteristic of the ionosphere is a very good idea, and that's what I will be following in the signal processor. Is I'll be locking onto the 24 carriers, checking their phase amplitude from a phase amplitude reference, and from that putting a phase amplitude correction back into each one of those carriers at the receiver. So the signal processor is taking a lot of time, and this is why I've taken time out from the project. That is getting quite involved in rebuilding those phase amplitude corrections. As I said, this mode is designed to work no matter what. So you're just going to get a very noisy picture with, say, QPSK. Of course, it's very phase dependent, phase amplitude dependent. Once those phase errors start building up, the error correction can't cope and it falls over. This system doesn't have that. It does not use error correction. It only uses noise reduction.
Okay, thanks, Grant. And one final question, I think, for you from Charles G4GUO. Do you have symbol rate restrictions on HF in Canada like the Americans do?
It's not really applicable, because it's not really digital, it's hybrid. I don't know how symbol rate would apply in this case, because
so,
it's basically a frame, it's a fixed frame,
yeah.
And so it fits within, depends on the mode, depending on which bandwidth you use. So it's a difficult one to answer, because it's not a conventional modulation system.
Well, one thing is for sure, that this certainly fit as part of our licenses. I guess in all parts of the world, the key word, I think, is probably experimentation. It's to encourage people to experiment, and you're certainly a great example of someone who's taken your license and experimenting and thinking of a new way of doing something. Thank you ever so much for joining us today with a brilliant presentation on narrow bandwidth television.
Okay, well, thanks for your time.
Many, many thanks, Grant. And that almost concludes the British Amateur Television Club CAT23 online convention, and we hope you've enjoyed it. Now, it was about to finish it, but I actually had a question which I shouldn't ignore, because it was actually asked of us, Tammy and me here in the studio, and it was from Julian Baldwin, who says, David, at the end of the show, could you give us a brief rundown on the equipment and resources needed to produce the show? Well, we weren't prepared. We didn't have background cameras or anything, and our cameras are fixed in the right positions, as you can imagine, for this. But what we did do a few minutes ago is we took a picture, a still frame, which Tammy's going to put up now, and I can just talk you through it. So this is what I'm seeing. You're looking at behind me. And there's about, I think we're using 6 computers today. So on the far left is an extra computer, which we're using for some extra media playback that we needed to do for films and videos and inserts and things like that. The big iMac on the shelf there, that's being used for one of the streaming. That's streaming, I think, to YouTube. And the next, then on the ground there, you can just see an audio mixer, and then next to that a vision mixer, which is for those of you interested, because of course most of these productions that we do, people aren't really interested in it, but this is a Roland V8 HD, which is very good. There's, on top of that is a monitor, preview monitor, showing all our different inputs and sources. Then behind my head on the left there is what we call our Caption Mac. That's running basically a sort of slideshow. We use Keynote, we use Macs exclusively here, and we're using basically a Keynote to put all of the captions and graphics and things that we might need in that. Countdown timers and things were videos as well that Tammy made up with those, and we started them at appropriate times so that we didn't have hard times for presenters to finish, because that wouldn't really work. The Mac that you can't quite see because my face is in front of it is where we're monitoring the BATC feedback, and that's also showing us the comments that you're asking on BATC. To the right of that you can just see there was Grant's head there. That's the Zoom computer, which is linked to our guest contributors with that. Above that you can just see we only use a couple of small Panasonic semi-pro cameras, which are HD, but they're really very, very good. There's a sort of homemade autocue above that, which isn't really an autocue as such. It normally just puts notes and things like that up from a script. There's a little piece of paper I stuck there if you look there with the running order of today. That's just in case something goes badly wrong and I have to very quickly fill, so I could have talked it over. To the right of that, another computer, that iMac there, that is streaming out to BATC and is also making a hard copy recording of it. So I hope that's interested those. I've never done that before, talk it through. I will just add one little thing, not to say that we've done a good job, but if you think we have, one of the reasons, to be honest though with all this, you can have all the equipment in the world, but if you don't do a bit of planning and preparation, and also we always insist on a technical rehearsal with all our presenters and guests. As you may know, we do a lot of these things now, both for our Norfolk Amateur Radio Club, which is what I'm chairman of and we're both members of, and also for the RSGB, and a lot of it just comes down to planning, and I think even the best professionals who have been doing it many years will agree with that. If you don't plan, then it doesn't really work. Even though the two of us are sitting next to each other, you need to know what's going to be happening. Hope that's provided a useful insight, and I'm sorry it's a long answer, but I hope it's enough. Maybe if you want us to do this again, what we could do is maybe put a little camera up in the ceiling or something and see a bird's eye view of it. That's just an idea, maybe for another year. But anyway, if this has been one of your first experiences of the British Amateur Television Club, then maybe you'd like to consider joining us, because membership starts at just £8 a year, which includes lots of benefits, including the magazines you saw earlier, weekly TV nets, events, and a very useful projects and parts shop. You can find full details about the club at www.batc.org.uk. So it's goodbye now from Vision Mixer Tammy M0TC, just off to my left, and myself. And after this short video, we'll go back to our chairman, Martin G4FKK, to formally close the convention. Bye-bye.
Well, thank you for that video there, and thank you to all the presenters for their time and effort, and for everyone for tuning in. I've got to ask David just now how many we've had. I think we had about 145 at one stage on the BAT streamer, but I'm not too sure how many we had.
It's about 145 to 2, and then about 45, 50 on YouTube.
Excellent. There you go. So that's good stuff. So I want to thank the speakers. Tim MW0RUD has finally got the timing settings on Ryde through my thick skull. So I did work out the other day, Tim, how to change the colour from red to, well, I've got it as a rather unpleasant yellowy green, but I can see why you chose red. It's much better. And Mike G0MJW, Mike stepped in right at the last minute to fill a gap we had in the schedule. And Mike, that was absolutely brilliant. You've convinced me to fire up KiCad, KiCad. That's the 3 versions of what it's called I've heard today. I'm going to move away from my old version of Eagle. That was very inspiring. And the 1.5mm 50 ohm track was useful too. Some encouraging news there regarding the Serrit replacement from Dave, GKQ. Thanks for doing that, Dave. It looks like there's plenty of planning going on and plenty of opportunities too for some future amazing gadgets. And the unrehearsed link up with Gilwell Park Scout Centre there, absolutely astonishing. I didn't realise Frank was such a great presenter, and Lawrence did some sterling camera work there with an iPad, I believe. So we just want to make sure the BBC don't poach you, Frank. Frank's also the CQTV editor, so where on earth he gets the time from, I don't know. And Michael, DL5OCD, unravelled some of the mysteries of DATV, not so easy. I say mysteries because I have downloaded it and decided maybe I'll wait for the GUI. But now I've seen how you drive it, Michael, I think I'll give that another crack. And Grant, that was absolutely brilliant. I kind of think the work you've done is more like a doctoral thesis, really, but you managed to explain it so that my aforementioned thick skull absorbed it all. So that's very good. So I shall now formally close the BATC CAT23, but not before a special thanks to David and Tammy giving up their time to make CAT23 online so slick and professional. That's amazing stuff. Thank you very, very much for that. And I'd also like to thank Mike MJW and Dave GKQ for the very long QSO they've had this today on Oscar 100. So thanks again. David's going to put a slide up where you can join the BATC, email the BATC, volunteer for the BATC, and etc. So thanks again. See you all at CAT24.